Introduction. An invitation to the cosmic shore. When night falls and the world grows quiet, there is a calm that comes from simply looking up. The sky becomes a vast ocean of light, and every star seems to drift upon its surface like a thought suspended in eternity. To gaze into that immensity is to feel the same serenity one finds standing before the sea, where the waves hush the noise of daily life, and the horizon seems to stretch forever. Astronomy offers that same stillness. It invites us to listen to the slow rhythm of the universe, to feel the gentle passage of cosmic time flowing all around us. This journey through the cosmos unfolds like a meditation on existence itself. It begins with the birth of time and light, tracing the architecture of the universe, the quiet geometry that holds galaxies and worlds in graceful balance. It leads us through the hidden realms of dark matter and dark energy, the unseen forces that shape everything we know. We drift among the stars, watching how they are born in silent clouds, how they live, die, and give their substance back to the cosmos. And finally, we return to the beginning, to the faint echo of the Big Bang that still hums across space, the first light that connects all things. Each part of this story reveals another layer of the same truth, that the universe is both vast and intimate, ancient and ever new. The stars that shine above us were forged in the same processes that made the atoms within our bodies. The dust that falls softly through space once burned in the hearts of suns. Even the faint microwave glow that surrounds us is the lingering warmth of the moment everything began. This is not just a story of physics, it is a story of belonging. To understand the cosmos is to find comfort in its quiet order, to recognize that we are not separate from it, but woven into its unfolding. Every breath we take, every heartbeat, every glimmer of thought is part of the same cosmic rhythm that began nearly 14 billion years ago. So let this journey be your invitation to drift at the edge of the cosmic shore, to listen, to reflect, and to find peace in the knowledge that we are made of stars, carried gently through the deep, patient silence of the universe.
Part 1. A Tapestry of Time and Light. Close your eyes for a moment and imagine standing beneath a quiet sky. Above you, countless stars shimmer like distant memories. Each one sends its light across unimaginable distances, carrying the story of what once was. The night sky is not a picture of the present, it's a living history, unfolding before your eyes in threads of light that began their journey long before human life began. Every photon that reaches us is a traveler from the past, a messenger from a moment that has already faded. Some of that light left its home just years ago. Some began its voyage millions, perhaps billions, before Earth even existed. Together, they weave a vast, shimmering fabric of time and space. To look up, then, is to look backward, to touch the deep past of the universe with nothing but your gaze. This is where our journey begins, on the threshold between now and eternity. In this part of our series, we'll explore how light connects us to the past, how telescopes act as time machines, and how even the stars we see tonight may already have ended their lives. We'll uncover the incredible story of the universe's 13.8 billion year history, its birth, its expansion, and the quiet patience with which it continues to evolve. And finally, we'll step into a humbling perspective where all of human history, every civilization, every dream, fits into the last heartbeat of cosmic time. This is not a tale of insignificance, but of wonder. In every chapter of the cosmos, we discover how deeply we belong to it, how the atoms in our bodies were once part of stars, how our awareness is the universe awakening to itself. So as you listen, allow the rhythm of your breathing to match the rhythm of the universe, slow, vast, and unhurried. Here, under the infinite tapestry of time and light, may you find peace in the knowledge that you are part of a story still unfolding, not written in ink, but in starlight.
Chapter 1. The light you see is an echo of the past. When we lift our eyes to the night sky, we are not simply seeing the present moment stretched above us. We are witnessing the past, painted in light. Every glimmer, every shimmer that trembles in the darkness, carries a story from long ago. The stars do not merely shine, they speak softly across impossible distances and unimaginable time. Light, though astonishingly fast, is not instant. It races at about 300,000 kilometers every second, the greatest speed allowed by the laws of nature. In our daily lives, this seems immediate. Light fills a room the instant we flip a switch. But space is vast beyond imagination. The distances between stars are so immense that even at this incredible speed, light takes years, centuries, or even millions of years to reach us. In the universe, time and distance are woven together, and light is the thread that connects them. When you stand beneath the sunlit sky, the light warming your face left the sun 8 minutes earlier. What you see is the sun as it once was, not as it is right now. During those 8 minutes, our planet has moved thousands of kilometers along its orbit. Winds have crossed oceans, and human lives have shifted in small, invisible ways. Yet the sunlight arrives, ancient in its own small way. Proof that even in the space of a few minutes, the universe gently reminds us that everything we see is history in motion. Now stretch that idea farther. Imagine the nearest stars beyond our solar system, in the Alpha Centauri cluster, more than 4 light years away. The soft radiance that reaches your eyes tonight began its journey before the last 4 cycles of Earth's seasons had even passed. Somewhere in that time, perhaps you had made choices, celebrated moments, or lost something precious. And while those things happened here, the light from Alpha Centauri was still crossing the emptiness, steady and unwavering,
destined to meet you tonight.
The farther we look, the deeper into time we travel. The faint, mist-like glow of the Andromeda Galaxy, the nearest major galaxy to our own, set out on its way some 2.5 million years ago. When that light began its voyage, the world was in an entirely different age. Early humans were crafting their first stone tools, chipping them by firelight or under the open sky of Africa. The Earth's climate was shifting toward what geologists call the Pleistocene epoch, a time when ice would carve valleys and shape continents, when mammoths roamed and vast glaciers covered the poles. The universe has been sending that light ever since, and only now, after millions of years, does it arrive to grace your eyes. To gaze at the night sky, then, is to read an archive older than any book or civilization. Every star, every cluster, every glowing cloud is a record of something that once was, a story frozen in light. Astronomers call this the look-back time. Even when they study distant galaxies through telescopes, they are not seeing what exists today, but what existed when that light first left. Some of the light captured by modern observatories, like the Hubble or the James Webb Space Telescope, has traveled for over 13 billion years, coming from the earliest galaxies born after the Big Bang. We are, in the most literal sense, watching the universe grow up, catching its childhood on film. And all of this is verifiable, grounded in the physics of space-time. Einstein's theory of relativity tells us that light speed is not just fast, it is the ultimate cosmic speed limit. Nothing can move faster. The light we see, then, becomes a kind of time machine, letting us witness events long gone. It reveals how galaxies evolve, how stars are born and die, and how the cosmos itself continues to expand like a great, slow breath. Think of this the next time you look up. Those pinpoints of light are not random decorations on a black canvas. They are silent messengers from the past. The glow of a distant star might carry the memory of a supernova that exploded before humanity existed. The soft silver arc of the Milky Way may contain stars forming right now, though we will not see their true light for generations. In this way, the night sky is both mirror and museum, a reflection of what was and a preservation of what remains. And in that awareness, a gentle peace arises. Our everyday concerns, deadlines, plans, arguments, begin to feel smaller, not unimportant, but contained within something grander. The universe has been unfolding for nearly 14 billion years. Civilizations will rise and fall, yet the stars will continue their quiet work, shining and fading according to natural rhythms that need no audience. You, me, and everyone who has ever lived are simply fortunate to exist at a time when the cosmos is visible to us, when our eyes can still receive the ancient light that has traveled so far to be seen. So, when night falls and you find yourself beneath the open sky, take a deep breath. Let your mind drift with the light itself, ancient, patient, unhurried. Somewhere out there, new photons are leaving their home stars at this very moment, beginning a journey that may take millions of years before touching another world. Perhaps one day beings elsewhere will see the light of our own sun and wonder, as we do now, what kind of life once looked up at their stars and felt small, yet deeply connected. Because to look up is to look back. To see the light is to hear the past whisper softly across space and time. And to understand that truth is to find calm in the knowledge that we are all made of the same starlight, forever part of the universe's quiet and continuing story.
Chapter 2. A telescope is a time machine. When you look through a telescope, you are not just gazing into space, you are looking across the ages. Every lens and mirror, every faint glimmer caught in the dark, is really a bridge through time. Because light moves at a finite speed, even the most ordinary starlight is a message delayed by distance. What you see tonight is never now. It is always then, the universe as it once was, quietly replaying its history for anyone patient enough to look. That is why astronomers sometimes call their instruments time machines. A telescope does not transport us through time, but it lets time come to us. It gathers ancient light, fragile, worn by travel, and focuses it into meaning. Each photon that strikes the detector of a telescope is an ancient traveler, a record of something that happened long ago. A star's birth, a supernova's death, a galaxy assembling its first spiral arm. Take the Crab Nebula, for instance. It lies about 6,500 light-years from Earth, within the constellation Taurus. To see it is to peer back roughly 6,500 years to an era when human civilizations were still carving their earliest tools from stone and bone. The Crab Nebula is what remains of a massive star that once burned fiercely before ending its life in a supernova. When that star collapsed, it released more energy in a few seconds than our sun will emit in 10 billion years. Historical records tell us that in 1054 CE, Chinese astronomers noted a guest star that suddenly appeared in the sky. It was so brilliant that for nearly a month it could be seen even during the day, shining beside the sun. For almost 2 years, it lit up the night before fading from view. Those observers were unknowingly recording the afterglow of a cosmic cataclysm that had actually taken place 6,500 years earlier. The light from the explosion had been rushing through space all that time before finally reaching their eyes and ours. Today, when telescopes study that same region, they reveal a beautiful, ghostly cloud expanding outward like the smoke of a long-extinguished fire. At its center spins the collapsed heart of the original star, a pulsar, an object only about 20 kilometers across, yet containing more mass than our sun. It spins roughly 30 times every second, emitting beams of radiation like a cosmic lighthouse. Those pulses, picked up by radio telescopes on Earth, are precise enough to keep time more accurately than any human-made clock. The pulsar's energy continues to feed the surrounding nebula, causing it to glow in shades of blue, pink, and violet, colors that telescopes can detect even if our eyes cannot. The Crab Nebula is not only a monument to destruction, but also a laboratory for renewal. From its dust and gas, new stars will eventually form, continuing the endless cycle of creation that defines our galaxy. In that sense, every telescope image of the nebula
captures both death and rebirth, the universe recycling itself in silence. Yet the Crab Nebula is only a nearby example. When astronomers turn their telescopes toward the farthest reaches of space, they witness times so remote that they defy ordinary imagination. Instruments like the Hubble Space Telescope, launched in 1990, and the more recent James Webb Space Telescope, which began observing in 2022, extend our sightline to the very dawn of the cosmos. Here's how they achieve this extraordinary feat. As the universe expands, light from distant galaxies is stretched. Its wavelength lengthens, shifting from the visible part of the spectrum into the infrared. This effect, called cosmological redshift, means that the farther away an object is, the older the light we receive and the redder it appears. Ordinary eyes cannot see infrared radiation, but Webb's instruments were built precisely for that task. Floating 1.5 million kilometers from Earth, shielded from the sun's glare, Webb acts like an enormous, cold eye, tuned to heat so faint it borders on nothingness. Through that sensitivity, Webb has captured galaxies as they appeared more than 13 billion years ago, just a few 100 million years after the Big Bang. One of its most distant discoveries, a galaxy known as JADES GSZ13-0, shows us the universe when it was only about 320 million years old. To put that into perspective, if the history of the cosmos were compressed into a single calendar year, Webb is showing us the first week of January. Those ancient galaxies are small and irregular, filled with bright, short-lived stars that forged the earliest heavy elements. Watching them is like witnessing the universe take its first breath. Every photograph from these telescopes, therefore, is a fragment of the cosmic record. The patterns of light, the faint smudges and filaments, are not merely images, they are timestamps. When stitched together, they form a long, unfolding film of creation. Astronomers study these frames to understand how the first stars ignited hydrogen, how galaxies clustered and collided, how dark matter shaped the skeleton of space itself. Each new observation is another thread in the grand tapestry of time, showing that our present moment is only a single frame in an infinite story still being written. It is humbling to realize that all of this, every star, every galaxy, every photon, follows physical laws that can be measured and tested. None of it is myth. It is the patient work of light obeying the same constants everywhere in the cosmos. When you think of a telescope as a time machine, you are not indulging in fantasy, you are acknowledging the simple truth that light carries history and that our instruments let us read it. So, the next time you see a photograph from Hubble or Webb, perhaps a swirling nebula glowing like a painted veil, or a deep field image scattered with thousands of galaxies, remember that you are not just looking outward, you are looking backward into a past that still illuminates the present. You are witnessing moments that once were now somewhere else in the universe, countless ages ago. In that realization lies a quiet kind of wonder. The night sky above you is not a static picture. It is a living chronicle of time itself. The light arriving tonight left its sources long before your ancestors took their first steps, long before mountains eroded or continents drifted to their current shapes. A telescope simply helps you see that truth more clearly. It opens a window into ages that would otherwise remain forever invisible. And in doing so, it reminds us that even across billions of years and unthinkable distances, the universe is still sharing its story, one photon at a time. Chapter 3. Some stars we see may already be gone. When you step outside on a clear night and look up, the stars appear eternal, quiet lanterns scattered across the darkness, steady and unchanging. Yet what meets your eyes is not the living present of the cosmos. It is a collection of memories, fragments of ancient light arriving from different centuries, millennia, and even ages long before the first humans walked the earth. The night sky is not a single moment frozen in time. It is a vast mosaic of many pasts, stitched together by the delay of light's long journey. Every twinkle you see began far away and long ago. The moon above you is only a second and a third in the past. The sun, 8 minutes. The nearest stars glow with light that left them 4 years ago, while the Andromeda Galaxy, faint and soft to the naked eye, shows us light that began its voyage 2.5 million years ago. When you gaze at the heavens, your eyes quietly become time travelers, gathering these different eras at once, the recent and the remote, the near and the almost unimaginably ancient, all mingled into one delicate panorama. Among these distant storytellers of light, one star captures the imagination more than most: Betelgeuse, the crimson beacon marking the shoulder of Orion. It is one of the largest and most luminous stars visible to the human eye, a true red supergiant about 700 light-years from Earth. If Betelgeuse were placed where our Sun now sits, its immense, swollen body would engulf Mercury, Venus, Earth, and Mars, and its outer layers would stretch nearly to Jupiter's orbit. It shines with a deep orange glow, unsteady and irregular, like the breathing of some vast celestial creature nearing its final rest. Astronomers know that Betelgeuse is in the last act of its life. It has burned through most of its hydrogen fuel and begun fusing heavier elements in its core. Deep inside, gravity and pressure are locked in a fragile balance that one day will collapse. When that moment comes, the core will give way in an instant, and the star will die in a core collapse supernova, an explosion so powerful that for weeks or months it will rival the brightness of the full moon. It will be visible even in daytime, casting shadows at noon. Eventually, the outward blast will fade, leaving behind a dense neutron star, perhaps spinning like a cosmic gyroscope. But when will that happen? On human scales, no one can say. It might happen tomorrow. It might not happen for another 100,000 years. Because Betelgeuse is 700 light-years away, any light from its future explosion will need 7 centuries to reach us. It could even have already happened, long before we invented the telescope, before Galileo looked at the moon, or Newton watched an apple fall. If Betelgeuse exploded in the year 1325, the light of that cataclysm would be racing toward us right now, still hidden in the silent corridors of space. One evening, perhaps generations from today, or perhaps tonight, the sky may bloom with a new star, bright and ghostly, announcing what truly happened centuries ago. This strange truth, the idea that we may be watching dead stars, brings a quiet humility. The universe broadcasts its story to us with an unavoidable delay. We live within that delay. Each photon of starlight is an emissary, leaving its home long before our civilizations existed, crossing the cold vacuum at the finite speed of light, until, by chance, it touches our eyes.
What we call the present sky is really an archive of moments already finished. Still, not every star is gone. In fact, the great majority of the lights we see each night are still burning today. The stars most likely to have vanished are the giants, the short-lived massive suns that live fast and die young. They consume their nuclear fuel in only a few million years, a brief flare compared with the quiet endurance of smaller stars like our Sun. A star like the Sun can live for around 10 billion years. Seeing its light from 1,000 light-years away is like looking at a person's face in a photograph taken an instant earlier. Hardly a difference at all. So while a handful of those bright points might already have faded, most are still there, still burning, still sending out fresh light that will one day reach eyes yet unborn. The odds favor life continuing in the stars we see, even if our perception of them trails slightly behind reality. When you think of the heavens this way, the night takes on a new texture. The constellations become living tapestries woven from time itself. Orion, not as a hunter frozen forever in the sky, but as a moving figure whose stars exist in different stages of their lives. Some may already be cinders, others still young, and their light, traveling at different ages, arrives together to form the pattern we recognize. Even the very act of stargazing becomes something profound. Each time you look upward, you are not only witnessing light, you are participating in the universe's memory. You are seeing what was, not what is. The photons striking your retina tonight began their journey when empires rose and fell, when mountains were higher and coastlines new. In their silent way, they connect you to everything that has ever been. And perhaps that is the greatest gift of all. Though the stars remind us of endings, of suns that will one day exhaust their fuel, they also remind us that light endures. Even after a star has died, its final messages continue to cross the void for centuries or millennia, ensuring that its existence is not forgotten. In this way, the cosmos itself teaches us about continuity, the persistence of energy, the endurance of beauty, the patience of time. So, when you look at Betelgeuse glimmering faintly in Orion's shoulder, let your mind wander. Maybe it is still burning, swollen and unstable but alive. Maybe it has already fallen silent, its last light still hurrying toward us. Either way, its glow tonight is real, a momentary gift from the past. And as you drift toward sleep, remember that the light entering your eyes this very moment began its journey before you were born, before your grandparents' grandparents were born. You are part of a conversation that began long ago, spoken in the oldest language of all, the light of dying stars, still crossing the darkness, still finding its home.
Chapter 4. The universe is approximately 13.8 billion years old.
When we speak of the universe, we often imagine the endlessness of space, vast, silent, and timeless. Yet the universe is not eternal in the sense of having no beginning. It has an age, a measurable story written in light and matter. A history that began 13.8 billion years ago with the event we call the Big Bang. That number, 13.8 billion, represents not guesswork or myth, but one of the most carefully measured facts in all of science. To understand how we know this, imagine the cosmos as a great ocean that began as a single drop, an explosion not of material bursting outward into empty space, but of space itself expanding in all directions. At its birth, the universe was inconceivably hot and dense, a glowing soup of energy and particles so thick that light could not move freely. For the first few 100,000 years, the cosmos was shrouded in an opaque fog of plasma. There were no stars, no galaxies, not even atoms as we know them, only a storm of subatomic particles colliding and merging in every direction. Then, around 380,000 years after that beginning, something extraordinary happened. The universe cooled just enough for the first atoms to form, hydrogen and helium, the simplest elements. As these atoms took shape, they captured free electrons that had been scattering light, and for the first time, the fog cleared. Light was released to travel freely through space. That light has never stopped traveling. It continues to this day, faint and stretched by billions of years of cosmic expansion, filling the universe like a gentle background hum. We call it the cosmic microwave background, the afterglow of creation itself. It is not visible to the human eye, but instruments built with exquisite sensitivity can detect it as a faint whisper of microwave radiation coming from every direction in the sky. It is quite literally the universe's oldest photograph, its baby picture. By studying that ancient light, scientists have been able to read the earliest chapter of the cosmos. It contains subtle ripples, tiny variations in temperature that are no more than a few millionths of a degree different from one another. These delicate irregularities are crucial. They are the fingerprints of the universe's first structure, the tiny density fluctuations that would eventually grow into galaxies, stars, and planets. Space agencies like NASA and the European Space Agency have built satellites to study this ancient light in extraordinary detail. Among them, the Planck satellite, launched in 2009, provided the most precise map ever made of the cosmic microwave background. From its data, scientists could measure the scale of those primordial ripples and compare their actual size to how large they appear to us today. That comparison, guided by the known laws of physics and the measured rate of cosmic expansion, tells us how much time must have passed for the universe to stretch from its infant stage to what we see now. The result is astonishingly precise. 13.8 billion years, give or take a few tens of millions. A margin so small, it's like guessing a person's age to within a few days. This number anchors everything else we know about cosmic history. It sets the stage upon which every star, galaxy, and planet has played its part. For nearly 10 billion years after the Big Bang, the universe was busy forming structures, galaxies assembling from clouds of gas, stars kindling in clusters, and black holes growing in the crowded centers of those early systems. Our own solar system, by comparison, is a recent arrival. About 4.6 billion years ago, long after the Milky Way had taken shape, a cloud of gas and dust within one of its spiral arms began to collapse under gravity's pull. The dust came from earlier generations of stars that had lived and died. Stars that had fused light elements into heavier ones deep within their cores and then scattered those elements back into space in spectacular explosions. From that recycled material, our sun ignited, and around it, the planets slowly coalesced. Earth was born from those remnants, a sphere of rock enriched with carbon, oxygen, silicon, and iron, the essential ingredients for everything that would follow. In that sense,
We are descendants not only of the Earth, but of the stars themselves. The calcium in your bones, the iron in your blood, the oxygen you breathe, all were forged in the hearts of long-dead stars, billions of years before our planet even existed. This understanding gives a profound perspective on time. When you look up at the night sky, you are seeing not only great distances, but also deep history. The stars you see tonight belong to a universe that has been expanding and evolving for nearly 14 billion years. A universe that existed for 9 billion years before Earth was formed. Our world in that grand timeline is young, a single note in an ancient symphony. The cosmic microwave background reminds us that the universe carries its own memory. Every photon of that ancient light has traveled for almost the entire age of everything, untouched and unchanged, passing through epochs that saw galaxies form and civilizations rise. When we capture those faint microwaves with our telescopes, we are literally touching the oldest light there is. And yet, in that vastness, there is a quiet comfort. The age of the universe is not a cold number. It is a measure of endurance. For billions of years, stars have lived and died. Galaxies have collided and merged. And through it all, the fabric of space continues to stretch, patient and steady. We live in a moment shaped by that long history, built from ancient dust, warmed by an aging sun that still burns with energy first set in motion when the universe was new. To know that the universe is 13.8 billion years old is to glimpse our place within something far greater than ourselves. It means that our existence, fragile, temporary, and small, is part of a vast, ongoing story that began with light, continues through us, and will echo onward for billions of years more. And as you close your eyes tonight, beneath a sky filled with ancient light, you might take a quiet breath and feel it, the deep, calm rhythm of a universe still unfolding, still expanding, still remembering its own beginning.
Chapter 5. All of human history occupies a blink on the cosmic calendar. When we try to imagine the age of the universe, 13.8 billion years, it becomes almost impossible to grasp. Our minds were never built to handle numbers that large. We think in the span of lifetimes, generations, perhaps centuries. Beyond that, time turns abstract, like a horizon fading into mist. To bridge that gap, astronomer Carl Sagan once offered a thought experiment so elegant that it reshaped how many people think about existence. What if we compressed the entire history of the universe into a single calendar year? In this cosmic calendar, the Big Bang would happen at the first instant of midnight on January 1st. Everything that has ever existed would unfold within that 1 year, from the birth of galaxies to the rise of human civilization, until finally the clock strikes midnight again on December 31st. On this scale, 1 day on the cosmic calendar equals roughly 37.8 million years. Each hour is about 1.6 million years, each minute around 26,000 years, and each second a mere 437 years. The entire story of humanity, from cave paintings to spaceflight, fits within the last few seconds of that final night. Let us walk through this cosmic year slowly. January begins in silence and fire, the Big Bang. Space itself bursts into existence, expanding faster than light, filling with energy so intense that even atoms cannot yet exist. By early March, galaxies begin to coalesce out of cooling gas. Our Milky Way forms in mid-March, one among hundreds of billions of other galaxies drifting through the growing universe. The cosmic summer passes in quiet grandeur. In early September, about 9 billion years after the beginning, our own solar system takes shape. The sun ignites from a collapsing cloud of hydrogen and helium, and the planets gather from the dust that circles it. Earth forms around September 6th, still molten and bombarded by asteroids. Within a few cosmic days, oceans appear, and life begins. Simple, single-celled, yet persistent. Through the long cosmic autumn, life on Earth evolves. For billions of years, microorganisms dominate the planet, transforming its atmosphere and laying the foundation for everything to come. Only by mid-December do complex plants and animals emerge. On December 24th, the dinosaurs appear, ruling the Earth for 4 cosmic days before an asteroid abruptly ends their reign on December 28th. The mammals that survive scurry in the shadows, waiting for their turn. By the evening of December 31st, the universe has nearly completed its year. It is 11:52 p.m. when the first anatomically modern humans appear on Earth. For almost all of cosmic history, there have been no eyes to look up at the stars, no minds to wonder where it all began. Then, in these final minutes, something remarkable happens. Awareness awakens. Humanity's presence on this calendar is a whisper at the end of time. The entirety of our recorded history, the rise and fall of empires, the invention of writing, the construction of cities, the creation of art and science, all unfolds within the last few seconds before midnight. Around 11:59:45 p.m., the first civilizations bloom in Mesopotamia, along the Nile, in the valleys of the Indus and the Yellow River. The pyramids rise just 6 seconds before midnight. The philosophers of Greece and the builders of Rome live and die in the final 5 seconds. As the clock nears its final chime, the modern world flashes into being in an instant. The Renaissance, the discovery of new continents, the Industrial Revolution, the age of electricity, the world wars, the landing on the moon, and the birth of the Internet all occur within the last second of the cosmic year. Everything we know as modern life is a flicker of light just before the calendar resets. And yet, this does not make us insignificant. Quite the contrary. In that final blink of time, something extraordinary has emerged. A species capable of looking back across the entire year and understanding it. The atoms that once burned in the hearts of ancient stars have become aware of themselves. We, the descendants of stardust, have learned to measure time, to name galaxies, to hear the faint echo of the universe's first light. Think of what that means. The cosmos spent almost 14 billion years preparing the stage for this moment, so that matter could organize itself into life, and life could become conscious. Every breath you take, every thought you think, is part of a story that began long before Earth even existed. The brevity of our appearance does not diminish its value, it magnifies it. In the cosmic calendar, our time is short, but it is illuminated by awareness. The fact that we exist at all, able to reflect upon our origins, is both rare and profound. Our moment may be brief, but it is bright, like a spark that reveals the vastness around it. As you imagine this great calendar closing, picture the final second of December 31st. Somewhere in that instant, humanity sends a probe beyond the edge of our solar system, carrying a golden record that says, "We were here." And as the clock strikes midnight and the year resets to January once more, the universe continues, expanding, cooling, evolving, indifferent yet magnificent. This perspective does not make life meaningless, it makes it precious. The awareness that all of human history fits within a heartbeat of cosmic time invites humility, yes, but also gratitude. For in this vast and ancient universe, we have been given a brief moment to see, to feel, to love, and to wonder. That moment is ours, and though it may be small on the scale of the cosmos, it is infinite in meaning. So as you lie beneath the same stars that have watched over Earth since September of that great cosmic year, let this thought settle in. You are part of the final shimmer of light in a universe still unfolding. And even if we last for only a second in the grand story of time, that single second is enough to fill eternity with awe.
Part 2. The Architecture of the Void. If the first part of our journey followed the threads of time and light, how they stitch the universe into a single unfolding story, this second part turns our gaze to the grand structure that holds it all, space itself. What seems like emptiness is, in truth, the vast architecture of the cosmos, an open framework so immense that every world, every galaxy, and every atom moves quietly within it. Here we discover that even the space between Earth and the Moon could cradle every planet in the solar system with room to spare. A silent gulf so wide that distance becomes almost sacred. We learn that our entire planetary family rides together through the Milky Way, circling its hidden heart in a slow, elegant orbit that takes hundreds of millions of years to complete. We realize that the stars above us, so many that they outnumber all the grains of sand on Earth, are only the faintest hint of the universe's abundance. As the chapters unfold, this vastness grows deeper. We come to see that the observable universe spans roughly 93 billion light-years across, not because light travels that far, but because the very fabric of space has stretched as it carries the story of creation outward. And within that boundless expansion lies an extraordinary calm, a universe of silence, where even the brightest explosions unfold without sound, and where nearly all of existence is made of space rather than matter. Finally, we arrive at a truth both humbling and comforting, that every patch of darkness in the sky, no matter how small, overflows with galaxies. Each one is a universe of its own, shining quietly across the endless night. This part of the journey invites you to drift with that realization, to feel the scale of the cosmos not as a burden, but as peace, to rest in the awareness that we are part of this vast, luminous geometry, the serene architecture of the void. Chapter 6.
The Moon's neighborhood can accommodate every planet. When you stand outside on a clear night and look up at the Moon, it feels close, comfortably near, like a companion that has always been within reach. You can trace its face, its familiar shades of gray, its tranquil glow. It seems like a small step beyond the sky, a distance humanity has already crossed. But that sense of nearness is an illusion born of our scale. The truth is that the space between the Earth and the Moon is not a narrow gap. It is a vast, silent gulf, so wide that every other planet in our solar system could fit within it, lined up side by side, and there would still be room to spare. The average distance between Earth and the Moon is about 384,400 kilometers, a number that rolls easily off the tongue, but is almost impossible to visualize. To the human mind, such distances resist comprehension. We are creatures of small scales. We measure life in steps, journeys in kilometers, and even the oceans and continents, vast as they are, still lie within our experience. But in the language of space, the span to the Moon is enormous. It's wide enough to fit Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, pressed together in a cosmic row, their combined widths totaling about 380,000 kilometers. If you placed them there, each world, from tiny Mercury to immense Jupiter, they would all rest neatly within the Earth-Moon corridor, with a few thousand kilometers still unoccupied, as if the universe had left a quiet margin of emptiness just to remind us how much room it has to give. To picture this, imagine standing in the darkened desert, the Moon hanging above the horizon, and trying to imagine, somewhere in that stretch of empty space, the giant body of Saturn with its rings, or the deep blue sphere of Neptune drifting beside it. Jupiter alone, with its stormy clouds and immense gravity, could swallow more than 1,000 Earths. Yet even with all these giants assembled together, there would still be a gap between the Moon and the final planet's edge. What seems from here like a short distance is actually a cathedral of space, vast, quiet, and breathtakingly empty. Our brains are not built to sense such emptiness. The Moon looks large in the sky because it's relatively close by cosmic standards, and our eyes misread that apparent size as proximity. The planets, by contrast, look like faint points of light, which tricks us into thinking they must be unimaginably distant. In truth, they are both enormous and far away. The only reason they appear so small is because distance shrinks everything to a whisper of brightness. It's one of the universe's quiet jokes. We are surrounded by vastness, but our senses can only see the surface of the small. Even this remarkable planet lineup works only on average. The Moon's orbit is not a perfect circle. It stretches and relaxes like a slow celestial breath. At its closest point, called perigee, the Moon draws nearer, about 363,000 kilometers away, and the planets would no longer all fit. But at its farthest point, the apogee, when it drifts to nearly 406,000 kilometers from Earth, there is more than enough space.
At that distance, even if you added the dwarf planet Pluto, there would still be tens of thousands of kilometers left untouched. Space upon space, silence upon silence. This realization offers a small but profound shift in perspective. Even in our cosmic neighborhood, space is not crowded. It is generous, expansive, and open. The regions between worlds are not filled with clutter, but with calm. Every orbit, every path around the sun is carved through vast distances of emptiness where light travels unhindered and sound rests softly across invisible threads. When we think of the universe, it's easy to imagine it as busy, a grand mechanical clockwork of moving parts. Yet the truth is gentler. Between the planets lies an abundance of stillness, a kind of spacious quiet that defines everything from the orbit of the moon to the edges of the known universe. Even our own solar system, which feels so familiar, is mostly made of emptiness. The sun's light spreads outward through a volume of space so immense that all its worlds, moons, and comets together would barely fill a fraction of it. And perhaps this is what makes the universe feel so peaceful when we contemplate it. It is not a chaos of matter, but a harmony of distances. Every world moves within its own lane, surrounded by room to exist, to spin, to orbit, without colliding or crowding. In this arrangement there is balance, and in that balance, a kind of serenity. When we look at the moon tonight, glowing softly over the dark horizon, we can remember that the void between us is vast enough to hold everything we know, every planet, every world we've ever studied. Yet that void is not frightening. It is beautiful, because it is space itself that gives the universe its order and grace. It is the quiet distance between things that allows them to shine. And in a way, that realization brings comfort. Just as the cosmos is defined not by its clutter, but by its openness, our lives too are framed by space. Moments of stillness that give shape to meaning. The space between breaths, between thoughts, between the seconds of a day. The space that allows light to travel, sound to rest, and peace to return. In the end, the emptiness between the earth and the moon is not an absence. It is presence, the space that holds everything else. To gaze upon that quiet gap is to see the universe as it truly is, vast, calm, and full of room for wonder.
Chapter 7. We are riding a galactic carousel. When we look at the night sky, we often imagine the stars as fixed points, tiny lamps scattered across a quiet dome. The moon rises, the constellations shift with the seasons, and yet there's a comforting illusion of stillness. But the truth is that nothing in the universe is ever truly still. Even as you sit here, the ground beneath your feet, the planet itself, and every grain of dust within our solar system is on a great and silent journey through the galaxy. Just as Earth orbits the Sun, our entire solar system orbits something far larger, the center of the Milky Way. It's a journey so vast that we cannot measure it in days or years, but in epochs. The Sun, along with its family of planets, hurtles around the galactic core at nearly 720,000 kilometers per hour, fast enough to circle Earth in just over 3 minutes. Yet the distances are so immense that at this staggering speed, it still takes about 230 million years to complete one full revolution. That span of time is called a galactic year. By that clock, Earth itself has lived through roughly 20 galactic years since its formation 4.6 billion years ago. The last time our solar system occupied its current position in the galaxy, the supercontinent Pangaea was forming on Earth, and the first dinosaurs had not yet taken their first steps. Life then was recovering from the planet's greatest mass extinction, known as the Great Dying. The continents were fused together under an orange, hazy sky, and the seeds of future forests were just beginning to spread again. It is humbling to think that while life has evolved, flourished, and nearly vanished many times over, the sun has been making its slow, circular voyage through the Milky Way without pause. At the heart of our galaxy lies the anchor of this vast motion, a supermassive black hole known as Sagittarius A star. It sits about 26,000 light-years away, hidden behind thick curtains of interstellar dust and gas. Though invisible to ordinary sight, astronomers have traced its presence through the gravitational dance of nearby stars. It is 4 million times more massive than our Sun, and yet smaller than the orbit of Mercury. This immense object does not pull us inward like a whirlpool. It simply defines the stage on which the entire galaxy moves. The Milky Way's spiral arms, the clusters of stars, the great clouds of gas, all of them revolve around this dark, silent center, bound by its gravity in a majestic and endless rhythm. Our path through the galaxy is not a flat circle, but a gentle wave. The solar system moves up and down through the thin, star-filled plain of the Milky Way like a slow cosmic tide. One full oscillation, a rise and fall, takes about 32 million years. When we are above the galactic plane, the night sky may hold a slightly different pattern of stars than when we drift below it. These motions are imperceptible to us, too slow to notice within a human lifetime, yet constant. The entire solar system, planets, comets, asteroids, and dust, rides together as one, like passengers on an ancient carousel whose music plays on scales too vast for the human ear to hear. And so, while we might feel rooted to a particular place, to a home, a country, a planet, we are in truth always moving. Every second we travel thousands of kilometers through the galaxy, carried along by the sun's invisible wake. Even the constellations, those familiar shapes we trace in the sky, are temporary alignments. Over millions of years, they shift and distort as their stars continue their own journeys through the galactic sea. To place our existence on this timescale changes everything. Consider the span of a single galactic year, 230 million Earth years. In that time, entire mountain ranges have risen and worn away. Oceans have opened and closed. Species have appeared, flourished, and disappeared forever. The dinosaurs emerged about 1 galactic year ago. Humanity, in comparison, has existed for a fraction so small it can barely be measured. The entire history of Homo sapiens, from our earliest ancestors to today, would occupy only a few heartbeats at the end of this immense cosmic year. But our brief moment does not make us insignificant. If anything, it connects us to something far greater. To know that we are part of a system that has been orbiting for billions of years is to sense the quiet rhythm of the cosmos moving through us.
Every sunrise, every change of season, every spin of the planet is part of this grand choreography of motion. Even as we sleep, we are gliding through the galaxy, turning with the Earth, circling the Sun, and sailing through the spiral arms of the Milky Way. Imagine it, our home, a small blue world tucked near the edge of a great galactic disk, spinning and orbiting in an intricate dance of gravity and time. Around us, billions of other stars are on their own paths, some moving faster, some slower, but all sharing the same vast rotation. The galaxy itself, 100,000 light-years across, turns slowly in the dark, its arms trailing like the spirals of a luminous whirlpool. We are one star among hundreds of billions, and yet our motion is part of this vast harmony. There is a gentle comfort in this perspective. The Earth beneath our feet, so solid and still, is actually in constant motion, carried through the galaxy on a journey that began long before life appeared. And though we cannot feel it, we are all passengers together, riding the same cosmic current. To realize this is to feel both small and connected. Small because our lifetimes are so brief compared to a galactic year, but connected because our atoms, our planet, and our sun are all woven into the same grand fabric of space and time. We are part of a story that began long before us and will continue long after. A story written not in words, but in orbits and light. So tonight, when you look up and see the band of the Milky Way arching across the sky, remember that you are inside it. You are moving with it, sailing through its spiral arm, orbiting its quiet heart. The stars you see are your fellow travelers, bound to the same unseen center, moving together through the endless night. The galaxy turns, time flows, and we, for this brief moment, are awake to witness the ride.
Chapter 8. There are more stars than grains of sand on Earth. If you've ever stood on a beach at night, with the sea whispering in the dark and the stars glimmering above, you may have felt the subtle kinship between the sand beneath your feet and the heavens overhead. Both are countless, immeasurable, and humbling. The soft grains slipping between your fingers seem infinite, yet even they are outnumbered. For every grain of sand on every beach, in every desert, and across every shore of our planet, there are thousands upon thousands of stars shining somewhere in the universe. Our Milky Way alone is a vast island of light, home to somewhere between 100 and 400 billion stars. That number alone feels beyond reach, but the Milky Way is just one galaxy among roughly 2 trillion others in the observable universe. Multiply those figures together, and you arrive at a number so large it barely fits inside imagination, a 1 followed by 23 zeros. That is about 200 sextillion stars. It is a quantity that no human could ever count, not even if they devoted a lifetime to each galaxy or whispered a new name for each star with each passing second for eternity. These are not abstract numbers. They are real, derived from light that has traveled across billions of years to reach our telescopes. In 1995, scientists decided to test the limits of what was visible. They pointed the Hubble Space Telescope toward a patch of sky that appeared completely empty, a small square of blackness no larger than a grain of sand held at arm's length. They left the telescope's eye open for more than 100 hours, letting it gather every faint photon of light from that tiny corner of the cosmos. When the image was finally revealed, it changed astronomy forever. What had looked like nothing was, in truth, overflowing with galaxies, more than 3,000 of them, each one containing billions of stars. Later, even deeper surveys, using Hubble and newer instruments, revealed tens of thousands of galaxies in similar fields. Extrapolated across the full dome of the sky, this meant that the universe contained not hundreds of billions of galaxies, as once thought, but trillions. The cosmos, it turned out, was more crowded with stars than any ocean is with grains of sand. To bring that closer to home, scientists have tried to estimate the number of grains of sand on Earth. Counting every beach, every dune, every desert plain, they arrive at roughly 7.5 quintillion grains, a 7 followed by 18 zeros. It's an almost incomprehensible amount. Yet even that mountain of sand is dwarfed by the universe's abundance. For every grain on Earth, there are about 10,000 stars out there. 10,000 distant suns burning quietly across unimaginable distances. And stars, we now know, rarely travel alone. Each one is not just a solitary point of light, but a solar system in its own right, often surrounded by worlds. Thanks to observatories like NASA's Kepler and TESS missions, astronomers have discovered thousands of planets orbiting other stars, so many that they've concluded planets are the norm, not the exception. On average, there is at least one planet for every star in the galaxy. That means there are likely more than 200 sextillion planets in the observable universe. Some are gas giants, larger than Jupiter. Others are small, rocky spheres not so different from Earth, all circling their own suns under skies we can only imagine. Contemplating such abundance is not about feeling small or insignificant. It is about recognizing the creative generosity of the universe. The cosmos is not sparse or lonely. It is filled with light, motion, and possibility. Every point of starlight that twinkles in the night sky is a reminder of this plenitude, a whisper that creation has never been stingy. Think of what this means for us. The light from the stars we see tonight began its journey long before the first humans walked the Earth. Many of those photons have been traveling for thousands, even millions of years, crossing gulfs so wide that our entire solar system would disappear inside a single pixel of their path. Yet they arrive here, to our small blue world, and fall gently onto our eyes. We, who are made from the dust of ancient stars, are now gazing back at the very cosmos that made us. The next time you find yourself walking along the shore, pause for a moment and look at the sand. Scoop up a handful and let it sift slowly through your fingers. Each grain represents not just one, but 10,000 suns, each perhaps with its own orbiting worlds, its own moons and winds and seasons. Somewhere among them might exist oceans, mountains, and skies as beautiful as our own. Somewhere, life might be looking back, wondering if it too is alone under the stars. Even in this vastness, there is a quiet comfort. The universe is immense beyond measure, yet it is made of the same elements that compose our bodies and our world. Hydrogen, carbon, oxygen, iron, the common threads of matter are everywhere.
Every breath we take contains atoms forged in the heart of some long-dead star. The infinity above and the smallness within us are not opposites. They are reflections of each other. So when you look up tonight and see the Milky Way stretching faintly across the dark, remember, what you see is not emptiness. It is abundance beyond counting, a living testament to the universe's endless capacity to create. The stars are not distant strangers, but kin, ancient, luminous relatives shining across the sea of time. And in that light, there is a quiet reminder that we too belong to the cosmos, part of its endless creation and patient beauty. Let that thought rest with you gently. The sky above and the sand beneath your feet are not opposites. They are both made of the same dust, the same stardust that has traveled, changed, and reassembled across billions of years. The universe has scattered itself across space and time, and one of its many outcomes, one quiet, conscious reflection of all that abundance, is you.
Chapter 9. The observable universe spans about 93 billion light-years. When we look up at the night sky, it's easy to think of the universe as vast, but still somehow measurable, as though if we just traveled long enough we could reach its edge. We imagine the universe as a sphere of stars and galaxies, with us somewhere in the middle, light from distant objects streaming toward us across the void. The truth, however, is far more subtle and beautiful. The universe, as scientists understand it, is about 13.8 billion years old. That number seems to suggest that the farthest light we can possibly see must come from galaxies roughly 13.8 billion light-years away. After all, light travels 1 light-year per year. So how could anything older or farther be visible? Yet, when astronomers trace the faintest, oldest light that reaches our telescopes, the afterglow of the Big Bang itself, they find that the observable universe is far larger than that. Its diameter stretches roughly 93 billion light-years across. The reason lies not in how light moves, but in how space itself behaves. Since the beginning of time, the fabric of space has been expanding. This is not an explosion sending galaxies flying outward through an empty surroundings, but a stretching of the very space between them. Every corner of the universe is moving away from every other corner, not because the galaxies are thrusting through a void, but because the void itself is growing. If we could shrink ourselves down to an unimaginably small scale and watch space expand, we would see the distance between every atom of cosmic matter slowly increase, carried along by the gentle inflation of the universe itself. To picture this, imagine a loaf of raisin bread rising in the oven. Each raisin is a galaxy suspended in the dough. As the dough expands, the raisins drift apart, not because they are moving through the dough, but because the dough itself is stretching. The farther apart two raisins are, the faster they seem to move away from each other as the bread rises. The same is true of galaxies. Those nearby drift away slowly. Those billions of light-years distant recede faster and faster, not because they are racing through space, but because the space between us and them is stretching, like the dough in the oven. And here lies the wonder. This stretching of space is not bound by the cosmic speed limit set by the speed of light. Einstein's rule, "Nothing can move through space faster than light," remains true, but it says nothing about space itself expanding. The road, so to speak, can grow faster than the car can drive. The light from very distant galaxies is caught in this slow tug-of-war, traveling toward us even as the universe carries it away. The ancient light we can observe today, the faint microwave glow of the Big Bang, has been traveling through expanding space for almost 13.8 billion years. Yet, while it journeyed, the universe didn't stay still. It continued to stretch, and that same light has been carried far beyond what a simple distance equals time calculation would suggest. The galaxies that emitted that light long ago were once much closer to us, but now, after nearly 14 billion years of cosmic expansion, their present-day distance is around 46.5 billion light-years. Multiply that in both directions, since the universe extends equally in all directions around us, and you get a diameter of roughly 93 billion light-years for the visible cosmos. That word, observable, is important because it defines a limit, not a boundary. The universe does not end at that distance. It simply fades beyond our sight. Beyond that horizon, galaxies continue to exist, forming, merging, and shining in regions that light will never reach us from. Their photons are forever trapped in the expanding web of space, unable to cross the widening gulf between them and us. It's a humbling realization. There are places in the cosmos whose light we will never see, no matter how long we wait. Not because our instruments are too weak, but because the laws of the universe itself forbid it. As the expansion of space accelerates, driven by a mysterious force we call dark energy, that horizon grows more absolute. Some galaxies that we can see today are already slipping beyond the reach of future observers. The light they emit now will never arrive. Slowly, silently, they will drift beyond visibility, leaving the universe that future civilizations will know, smaller and emptier than the one we can see tonight. And yet, within this limitation, there is a strange kind of peace. The universe does not need to be infinite for its beauty to be boundless. Even within our observable bubble, we glimpse billions of galaxies, each one containing hundreds of billions of stars, each star perhaps encircled by planets and moons of its own. What lies beyond that horizon only deepens the sense of wonder, for it reminds us that the universe is larger than our imagination and always will be. To think that we live inside such a grand structure, an expanding sea of galaxies tens of billions of light-years across, is to feel both small and profoundly connected. Every particle of our bodies, every molecule of air we breathe, every photon that warms our skin, participates in this cosmic unfolding. The atoms that make us once drifted through clouds of hydrogen in the young universe, drawn together by gravity, shaped by time, and eventually assembled into stars, planets, and people. So when we gaze up at the night sky, we are not just looking across space, we are looking across time itself. The stars we see shine from different epochs of the universe's history, their light crossing a cosmic landscape that has been stretching and reshaping since the dawn of creation. Beyond what we can see lies more, vast regions of existence that will forever remain hidden, unreachable, yet real.
There is comfort in that thought. The universe is larger than we can ever measure, more mysterious than we can ever fully know. But it is not chaotic. It follows patterns written into the very fabric of physics. Light still travels, gravity still binds, and the rhythm of cosmic expansion continues. Steady, patient, eternal. Somewhere out there, far beyond the horizon, galaxies drift in silence, their light eternally on its way, but destined never to arrive. And here, on our small blue planet, we watch the edge of the observable universe with instruments of glass and mathematics tracing the faint afterglow of the beginning, and knowing that beyond that faint edge, the story still goes on.
Chapter 10. A universe of silence and near-perfect nothingness. The universe dazzles us with its beauty. Swirling galaxies, glowing nebulae, the soft shimmer of starlight scattered across the night sky. From afar, it appears alive with motion, drama, and color. We imagine these sights accompanied by sound, the roar of explosions, the hum of distant engines, the crackle of energy. Yet, if you could drift there yourself among the stars, you would hear nothing, not a whisper, not even the faintest murmur. The cosmos is a stage of unimaginable power performed in utter silence. Space, despite its radiant displays, is a near-perfect vacuum. Sound, as we know it, needs a medium to travel: air, water, or solid matter. It is the trembling of molecules, a ripple of vibration passed from one particle to another. But in the depths of space, there are almost no particles to carry such ripples. Even a supernova, one of the most energetic events in nature, unfolds in perfect quiet. A single supernova can release in seconds more energy than our sun will emit over its entire 10 billion-year lifetime. It can outshine a galaxy of billions of stars, flaring across cosmic distances. And yet, if you were close enough to witness it, you would hear nothing at all. Only a blinding burst of light spreading outward through the void. The silence of space is one of its most haunting qualities. It is not the silence of peace after noise, but the deep and eternal quiet of emptiness itself. Every motion, every collision, every beam of light takes place without sound. In this way, the universe feels both powerful and serene, a paradox of infinite energy unfolding in perfect stillness. It is as if creation itself prefers calm to chaos, as though the grandest cosmic events take place in meditation rather than in fury. And yet, while space may be silent to our ears, it is far from inactive. The universe hums with invisible vibrations, radio waves, electromagnetic fields, and the subtle ripples of space-time itself. These are not sounds in the ordinary sense, but they can be translated into frequencies we can hear. When scientists convert the signals from the cosmos into audible tones, the silence comes alive with unexpected music. Planets like Jupiter, for instance, emit streams of radio energy shaped by their immense magnetic fields. When transformed into sound, they become ghostly, whistling waves, like wind across an unseen ocean. The collision of black holes, detected through gravitational waves by observatories like LIGO, creates a rising chirp, a faint climbing note
produced by the final moments before two massive objects merge into one. These are not imaginary sounds, they are real physical signals, made audible through translation. They remind us that the universe is filled with rhythm and pattern, even if we cannot hear it directly. But the silence is only half the story. The other is the emptiness itself, the vast, generous void that makes everything else possible. Between stars, between galaxies, space is almost perfectly empty. Inside our galaxy, the region we call interstellar space contains, on average, about 1 atom in every cubic centimeter. That may sound small, but to grasp it, imagine holding a sugar cube in your hand. The air inside that cube here on Earth contains roughly 10 quintillion atoms, 10 billion tiny particles. In the same volume out between the stars, there would be just one. And between galaxies, the emptiness becomes even more profound. Intergalactic space, the dark ocean between the great clusters of galaxies, contains on average less than 1 atom in an entire cubic meter. A cubic meter is the size of a washing machine, a space large enough for a person to stand inside. Imagine a single lonely hydrogen atom drifting in all that volume, separated by kilometers of nothingness from the next one. Even the best vacuum chambers built on Earth cannot compete with that level of emptiness. The strongest laboratory vacuums are billions of times denser than intergalactic space. The cosmos, it turns out, is not mostly made of stars and planets, it is mostly made of nothing. More than 99.999999% of the universe is void, an endless gulf where matter is the rare exception, not the rule. And yet, this emptiness is not desolation. It is the quiet foundation on which everything else rests. Without the vast stillness between galaxies, their light would have no room to travel. Without the empty spaces between atoms, matter could not form or move. Even within our own bodies, emptiness dominates. If you could remove all the space inside the atoms that compose you, your entire mass would fit into something smaller than a grain of sand. The universe's nothingness is not a flaw. It is the condition that allows existence itself to be. When we contemplate this cosmic silence, we find a kind of peace mirrored in ourselves. The same laws that keep the stars burning also ensure that most of the cosmos remains tranquil. The same emptiness that fills the universe also fills every atom of our being. We are born from this quiet fabric of space, and when we look up at the night sky, we are gazing into the same deep stillness that gave us form. It is easy to think of the universe as violent or chaotic, a place of collisions, explosions, and extremes. But seen through the lens of silence, it becomes something different. A place of balance, patience, and quiet rhythm. Even the loudest forces, supernovas, quasars, and black holes, unfold with grace, following laws that have not changed since the dawn of time. There is harmony even in destruction, order even in vastness. If you could float there, between galaxies, far from any light, you would find yourself immersed in this grand stillness. Around you, the faint glow of distant galaxies would shimmer like grains of dust suspended in darkness. There would be no wind, no sound, no sense of motion, only the quiet pulse of your own heart and the slow drift of eternity. You would be surrounded by near-perfect nothingness, yet it would not feel empty. It would feel spacious, calm, infinite. Maybe this is why the idea of cosmic silence feels so comforting. It reminds us that stillness is not absence, but presence, the pure state in which all things arise and fade. Just as the spaces between notes make music possible, the silence of the universe makes creation possible. Within this great quiet, galaxies form, stars ignite, and life begins to think, to wonder, to listen. So tonight, as you close your eyes, imagine yourself drifting through that boundless calm. The stars shine without sound, their light gliding silently across the dark. Between them stretches the endless breadth of the cosmos, vast, tranquil, and alive with potential. The same silence that fills the universe fills you too, a quiet reminder that even in the stillness, everything is connected.
Chapter 11. A Speck Teeming with Galaxies. If you stand beneath a clear night sky and gaze upward, you might notice patches of darkness between the stars, those quiet spaces where nothing seems to shine. To the naked eye, they look like voids, gaps in the tapestry of the cosmos. But the universe often hides its abundance behind simplicity. When astronomers aimed their telescopes into one of these seemingly empty corners of the sky, they discovered that what appears as nothing is, in truth, everything. In 1995, the Hubble Space Telescope performed an experiment that would change our understanding of the universe. Astronomers pointed it toward a small dark patch in the constellation Ursa Major, a region that looked utterly blank. The area was so tiny that if you held a grain of sand at arm's length, it would cover it completely. Many thought it was a waste of time, precious hours of one of humanity's most advanced instruments aimed at nothing at all. But they let the telescope stare into that darkness for over 100 hours, collecting every faint photon of light that drifted in from deep space. When the images came back, they revealed something astonishing. That empty patch of sky was not empty at all. It was overflowing with galaxies. More than 3,000 of them crowded into that single image, each one containing billions of stars, each with its own possible worlds, nebulae, and suns. Every point of light was not a star, but an entire galaxy. The darkness had been an illusion. What looked like void was, in reality, a dense forest of light, stretching across billions of years of cosmic history. That picture became known as the Hubble Deep Field, and it remains one of the most profound photographs ever taken. It captured in one frame both the immensity of the cosmos and the miracle of our own perspective. We realized that if a single pinprick of sky could contain thousands of galaxies, then the entire observable universe must be populated by trillions. Everywhere we look, space teems with structure and light, the quiet architecture of creation repeating itself across unthinkable scales. But the story didn't end with Hubble. Decades later, a new eye was opened to the universe, the James Webb Space Telescope.
While Hubble saw invisible light, Webb could see in infrared, allowing it to peer through clouds of cosmic dust and glimpse the faint, red-shifted glow of galaxies so distant that their light had traveled for nearly the entire age of the universe. When Webb turned its golden mirrors toward a similar patch of darkness, it revealed even more. Behind Hubble's thousands of galaxies were tens of thousands more, older, smaller, and more primitive. Some of them existed only a few 100 million years after the Big Bang. Webb had extended our sightline deeper into time, revealing the cosmic dawn when the first stars and galaxies were born. Looking at those deep-field images is like gazing into a time capsule that contains the entire story of the cosmos. In one photograph, you can see galaxies in every stage of life. Some are majestic spirals, arms of starlight swirling like seashells, rich with gas and newborn suns. Others are massive elliptical clouds of aging stars, galaxies that have long since burned through their fuel and settled into quiet, golden maturity. And between them are the irregular ones, clumpy, chaotic, half-formed galaxies, still gathering themselves under gravity's patient hand. Each represents a different chapter in the history of cosmic evolution. It is strange and beautiful to think that in a single image you can see the universe growing up. The nearby galaxies appear as they are now, but the faint red smudges at the edge of the frame show the universe as it was over 13 billion years ago, when light first began to travel freely through space. To look at these pictures is to hold billions of years of cosmic memory in a single glance. The abundance revealed by these telescopes is staggering. Our own galaxy, the Milky Way, once seemed unimaginably vast, a grand spiral of hundreds of billions of stars. But now we know it is only one among perhaps 2 trillion galaxies within the observable universe. Each galaxy is a miniature universe of its own, with its own clouds, clusters, and solar systems. Together, they form an endless cosmic web, connected by filaments of dark matter, stretching across space like a vast network of glowing islands adrift in an invisible sea. And yet, despite this unimaginable multitude, these discoveries carry a quiet reassurance. The immensity of the cosmos does not make us small. It gives our existence context. We are part of something unimaginably vast and alive. The same physical laws that shape distant galaxies also shape the atoms in our bodies. The same light that travels billions of years to reach a telescope's mirror also touches our skin on a warm morning. In the grand scale of things, our lives may seem like fleeting sparks, but they are made of the same light that fills the universe. To gaze into a deep-field image is to see the universe as it truly is, not empty, but overflowing, not static, but alive. Every speck, every glimmer, every faint patch of color in those images represents billions of worlds, billions of suns, and perhaps billions of stories waiting to unfold. It is a humbling reminder that our night sky is not a ceiling, but an ocean. And somewhere in that ocean, our tiny world drifts, a single dot around a modest star, tucked inside the quiet arms of one galaxy among trillions. Yet it is from this small place that we have learned to look outward, to gather ancient light and turn it into understanding. The photons captured by Hubble and Webb began their journey long before our species existed. They crossed time and distance to arrive here, at this moment, to tell us that the universe is not an expanse of nothingness, but a living tapestry of light and time. In that realization lies both wonder and comfort. The universe does not revolve around us, but it includes us. The same cosmic forces that shape galaxies shaped our world, our breath, our thoughts. To see the abundance of galaxies is to feel that we are not lost in infinity, we are part of it. The vastness of the cosmos is not something to fear, but something to rest within. It is the great quiet background against which every life, every planet, and every star has meaning. So the next time you look up at the night sky, remember, even the darkest space between the stars is not empty. It is alive with light from countless galaxies, each one whispering its story across the ages. The universe, it turns out, is a speck teeming with galaxies, and we are one of them, quietly shining in the grand stillness of it all.
Part 3. The Unseen Majority. As our view of the cosmos has deepened, we've discovered that what we see, the stars, the glowing galaxies, the swirling clouds of light, is only a fraction of reality. Beyond the luminous veil lies a vast and invisible realm, a hidden structure that silently shapes everything we know. This part of our journey explores that unseen majority, the dark matter that binds galaxies together, the dark energy that drives them apart, and the ultimate horizon beyond which light itself can never return. These are not just scientific ideas, they are quiet invitations to wonder. They remind us that the universe we inhabit is both mysterious and harmonious, that its most powerful forces are invisible, and its grandest truths are whispered, not shouted. As we drift deeper into the darkness, let the thought bring comfort rather than fear. The unknown is not an emptiness waiting to be filled. It is the gentle background against which every star, every planet, and every thought shines. This is the unseen universe, silent, immense, and profoundly alive. Chapter 12. Only about 5% of the universe is visible matter. When we gaze at the night sky, what we see feels infinite. The glow of stars scattered across the blackness, the faint smudge of our galaxy's arms stretching like mist, the pinpoints of light that may be other suns, other worlds. It is easy to believe that this visible universe, the galaxies, the nebulae, the clusters of stars, is everything there is. But science, in its quiet and patient way, has revealed something astonishing. Everything we can see, touch, or measure directly, the totality of luminous matter, makes up less than 5% of the universe. The rest, 95%, is hidden. It neither shines nor absorbs light, yet its fingerprints are woven through everything. It is one of the most humbling discoveries in modern cosmology. For all our telescopes and instruments, for all our deep-field photographs and space missions, we have only begun to glimpse the surface of a far greater reality. The universe, it seems, is like a grand ocean, and all the shining galaxies we observe are only the foam upon its surface. Scientists have learned this not by seeing the unseen, but by tracing its subtle effects, its pull, its push, its quiet shaping of the cosmos. Two invisible components dominate the universe: dark matter, which binds galaxies together, and dark energy, which drives them apart. Together, they form the silent framework of existence. Dark matter, which makes up about 27% of the universe, is like an invisible skeleton holding everything in place. We cannot see it, but we can sense its gravity. The first clues came from how galaxies spin. Imagine a vast spiral galaxy, like our own Milky Way, rotating through space. The stars at the outer edges move far faster than they should if the galaxy's mass came only from the matter we can see: stars, dust, and gas. By the normal rules of gravity, those stars should be flung into the void, spinning off into darkness. But they remain bound, as though an unseen hand holds them in orbit. This unseen hand is dark matter, a halo of invisible mass surrounding every galaxy. It does not glow, it does not collide, but its gravity sculpts the universe. Without it, galaxies could not form or survive. In a sense, every star we see is resting in the quiet embrace of this hidden framework. Even now, our own solar system drifts within a vast halo of dark matter that surrounds the Milky Way, though we pass through it without ever noticing. Astronomers have found other ways to trace its presence. When light from a distant galaxy travels through space, it sometimes passes near a massive object, like a cluster of galaxies, on its journey to us. The gravity of that invisible mass bends and magnifies the light, distorting the background galaxy into arcs or rings. This phenomenon, called gravitational lensing, acts like a cosmic fingerprint of dark matter. We see the bending, but not the bender. The light reveals the presence of an invisible structure, billions of times more massive than anything we can see directly.
And yet, even dark matter, vast and mysterious as it is, accounts for only a portion of what we are missing. The greater mystery, dark energy, is stranger still. It makes up about 68% of the cosmos, and behaves like a force that pushes rather than pulls.
For much of the 20th century, scientists assumed that the universe's expansion, set in motion by the Big Bang, would gradually slow down. Gravity, pulling on every particle of matter, should have been drawing everything back together. But in the late 1990s, when astronomers studied distant supernovae, brilliant stellar explosions that serve as cosmic milestones, they discovered something unexpected. The light from these supernovae was dimmer than it should have been, suggesting that they were farther away than anticipated. The only possible explanation was that the expansion of the universe wasn't slowing down at all. It was accelerating. Something everywhere was pushing galaxies apart. That something became known as dark energy. Unlike dark matter, it isn't a substance or a collection of particles. It is a property of space itself, a gentle pressure woven into the very fabric of the cosmos. As the universe expands, dark energy doesn't thin out. It remains constant, driving the expansion faster and faster. This revelation changed everything. The universe is not only vast, but it is growing more vast with time, accelerating toward a future of greater distance and deeper silence. The galaxies we can see now are slowly slipping away, carried beyond our cosmic horizon by the quiet force of dark energy. In billions of years, many of them will fade from view entirely, their light forever out of reach. The universe, in its expansion, is revealing both its generosity and its mystery. That leaves the remaining 5%, the familiar matter of stars, planets, and people. Scientists call it baryonic matter, the ordinary material made of protons, neutrons, and electrons. It includes everything that burns, shines, or breathes. It is the stuff of clouds and oceans, of mountains and hearts, of every planet orbiting every sun. And yet all of this, all the galaxies that fill our telescopes, all the atoms that make up our bodies, amounts to only a trace of the universe's full composition. In a way, this realization is both humbling and comforting. It reminds us that reality is far deeper than appearances. We live in a cosmos where the known floats upon the unknown, where the visible world is but a whisper of a greater whole. But this does not make our part insignificant. On the contrary, it makes it precious. We, the creatures of that luminous 5%, are the part of the universe that can wonder about itself. We are made of the same particles that once formed inside stars, and it is from that same visible matter that eyes were shaped to look outward and ask, what else is there? To think that 95% of the universe is invisible to us is not discouraging. It is inspiring. It means there is still mystery left, still discovery to be made, still awe to be felt. The darkness of the cosmos is not an emptiness, but a promise. It invites us to keep searching, to keep learning, and to keep marveling at how much there is beyond our reach. The light that we see from stars and galaxies may only illuminate a small fraction of the whole, but within that light is the key to everything we know, the chemistry of life, the warmth of our sun, the glow of distant worlds. In that narrow window of 5% lies the story of our existence. The rest, the silent ocean of dark matter and dark energy, reminds us that creation is far greater than our senses can perceive. As we drift in our tiny world, bathed in the glow of a single star, we can take comfort in knowing that we are part of something vast and ongoing. The universe, though mostly hidden, continues to unfold around us with patience and order. The dark and the light, the seen and the unseen, together form a single harmonious whole. And in that balance, between what we know and what we do not, there is beauty.
Chapter 13. Dark Matter. The Invisible Scaffolding. When we look into the night sky, we see the glittering bones of the universe, stars, galaxies, and glowing clouds of gas. They give the illusion that we are seeing the whole of creation, that the visible light scattered across the darkness represents the true shape of the cosmos. Yet what we can see is only the faintest hint of a much larger structure. Beneath this luminous surface lies something vast and unseen, dark matter, the invisible framework that holds the universe together. We know it is there, even though no telescope has ever captured it.
Its existence is revealed through gravity, the one language it speaks. In the mid-20th century, astronomers studying galaxies noticed something strange. Galaxies were spinning so fast that by all ordinary calculations, they should have torn themselves apart. The outer stars, moving with such speed, should have escaped into intergalactic space. Yet they did not. The galaxies held together, as if cradled by a hidden hand. This was the first great clue. There had to be something else, some invisible mass providing the extra gravity to keep these systems intact. This unseen component became known as dark matter. Not dark because it absorbs light, but dark because it does not emit or reflect any. It simply cannot be seen. And yet, its gravity shapes everything we do see.
Over time, evidence of dark matter began to appear everywhere astronomers looked. Clusters of galaxies, great families of hundreds or thousands of galaxies bound together, moved in ways that suggested far more mass than could be accounted for by stars and gas alone. Even the afterglow of the Big Bang, the cosmic microwave background, bears the subtle imprint of dark matter. In the faint patterns of that ancient radiation, scientists can read the fingerprints of this invisible component, woven into the earliest moments of the universe. To see what cannot be seen, astronomers turn to light itself, not its presence, but its path. When light travels through space, it bends as it passes near massive objects, curving along the warps of space-time predicted by Einstein. Sometimes, when a massive clump of matter, visible or not, sits between us and a distant galaxy, its gravity acts like a lens, distorting and magnifying the light that reaches us. Through these delicate distortions, called gravitational lensing, we can trace where the invisible matter lies. It reveals itself as arcs, rings, and ghostly smears in telescope images, whispering the outline of what no eye can see. From these measurements, a pattern has emerged, a cosmic architecture of staggering beauty and scale. Dark matter is not scattered randomly. It forms a vast, interconnected web stretching across the universe, an invisible network of filaments and knots that define the shape of everything else. Astronomers call this structure the cosmic web. At its densest points, dark matter pools into massive halos, gravitational wells deep enough to attract ordinary matter. It is within these invisible basins that galaxies take root. Gas flows into the hollows, condenses, ignites, and forms stars. Without dark matter, there would be no galaxies at all, no stars, and no worlds. The visible universe is, in truth, a delicate frost forming upon an invisible scaffold. Even within our own Milky Way, dark matter dominates. The luminous disk of stars, with all its spiraling arms and glowing clouds, is only a thin layer resting inside a gigantic, unseen halo that extends far beyond what our telescopes can detect. The Earth, the Sun, and every star you can see tonight are moving within this halo like motes of dust drifting inside a vast, transparent bubble. With each orbit around the galactic center, we pass through regions filled with invisible particles that slip silently through us, unnoticed and unhindered. Scientists do not yet know what dark matter is made of. It may consist of particles that barely interact with ordinary atoms, so elusive that trillions pass through your body every second without leaving a trace.
Experiments deep underground and in orbit are searching for them, patiently waiting for a rare collision that might reveal their nature. So far, these particles remain hidden, but the evidence of their existence is overwhelming. They are the silent majority of the universe, the unseen foundation beneath all structure and form. The role of dark matter in cosmic history is immense. In the early universe, only a few 100,000 years after the Big Bang, ordinary matter existed as a thin, hot mist. On its own, it could not have clumped together to form galaxies. It would have remained a smooth fog for billions of years. But dark matter began gathering much earlier. Its gravity pulled the first structures together, creating invisible wells that ordinary matter could fall into once it cooled. The galaxies, clusters, and superclusters we see today all grew within these ancient frameworks. Every star ever born, including our Sun, was kindled inside the invisible architecture that dark matter built. In this sense, dark matter is not a mystery to fear, but a quiet presence to marvel at. It reminds us that what gives form to the universe is not always visible, not always luminous. The great beauty of the cosmos, its spirals, its filaments, and glimmering dust lanes, rests upon foundations we cannot see. We are shaped by the unseen. When you look up at the stars, you are only seeing the glittering skin of a much deeper reality. Beneath that shining surface lies the cosmic scaffold, vast, ancient, and silent, holding galaxies in its gentle gravitational embrace. Without it, the universe would be formless and dim, a smooth haze instead of a living structure. With it, there is order, rhythm, and light. And perhaps that is one of the quiet lessons hidden in this story, that much of what truly sustains the universe, and even our own lives, is invisible. Not absent, just unseen. In every galaxy spinning gracefully through the night, dark matter holds the pattern steady. It is the unacknowledged architect, the calm hand beneath the dance of stars.
Chapter 14. Dark Energy, a Mysterious Repulsion. For most of human history, the universe was thought to be static, eternal, unchanging, held in perfect balance. Even after the discovery that space itself was expanding, scientists assumed that gravity, the great gatherer, would eventually slow this expansion down. Perhaps, over immense ages, the galaxies would drift to a halt and begin to fall back toward one another, collapsing into a fiery finale known as the Big Crunch. It was a neat and symmetrical vision, a universe that begins and ends in the same place. But in the late 1990s, that picture shattered. Astronomers studying distant supernovae, exploding stars used as cosmic mile markers, found that these celestial beacons were not where they were expected to be. They were fainter, farther, and older than any model could explain. The universe was not slowing down at all. It was speeding up. This was a revelation as profound as any in science. Something unseen, something woven into the fabric of space itself, was pushing the cosmos apart. That invisible force was named dark energy, though dark here means not sinister, but unknown, hidden from our senses, known only through its influence. Dark energy now appears to be the dominant ingredient of the universe,
accounting for nearly 70% of everything that exists. It is not matter. It is not radiation. It does not gather, clump, or shine. It behaves more like a property of space itself, a gentle, omnipresent pressure that stretches the universe wider with every passing moment. Gravity, which pulls, and dark energy, which pushes, are locked in a cosmic balance. For billions of years after the Big Bang, gravity was stronger, slowing the initial burst of expansion. But as the universe grew larger and matter spread thinner, gravity's grip weakened. Then, about 5 billion years ago, dark energy overtook it. Since then, the cosmic expansion has been accelerating, like a vast tide that will never turn back. The evidence for this comes from the light of the supernovae themselves, Type Ia supernovae, to be precise. These stellar explosions occur when a dying white dwarf star steals matter from a companion until it can no longer support its own weight. The resulting detonation is so consistent in brightness that astronomers use it as a standard candle, a reliable measure of cosmic distances. When the light from these explosions was compared across billions of light-years, the conclusion was inescapable. The universe's expansion had entered a new phase of acceleration. At first, the discovery was met with disbelief. It upended decades of theory and intuition. Yet as more data poured in, from supernovae, from the cosmic microwave background, and from the distribution of galaxies, the case only grew stronger. Space itself was changing in a way that no one had predicted. What then is dark energy? That remains one of the greatest mysteries in all of physics. Some scientists describe it as a cosmological constant, an intrinsic energy of space, first proposed by Einstein and later abandoned by him. Others suspect it may hint at new physics beyond our current understanding, perhaps a field that evolves slowly over time, or a property that emerges from the geometry of space-time. Whatever it is, it defies all ordinary categories. It does not flow, it does not dilute, and it does not seem to fade with distance. As the universe expands, new space, and therefore new dark energy, comes into being, ensuring that the push continues endlessly. The implications are both vast and intimate. Dark energy dictates not only the shape of the cosmos, but also its destiny. If its repulsive effect remains constant, galaxies beyond our local group will continue to drift away, faster and faster, until they vanish beyond the cosmic horizon, their light forever unreachable. In the far future, perhaps hundreds of billions of years from now, the night sky may appear empty to any observers who remain. No faint glows of distant galaxies, no map of the universe beyond their own island of stars. The cosmos will seem still, not because it has stopped expanding, but because expansion will have carried everything else away. This fate, sometimes called the Big Freeze, is a universe growing ever colder, ever darker, and ever lonelier. Yet there is something serene about this image. It is not a violent end, but a quiet, graceful fading, a cosmic exhalation that never quite finishes. The energy that drives it, though mysterious, is not hostile. It is simply the natural rhythm of a universe still evolving, still creating space for itself. And so, even as we stand on our small planet, circling a single star in a quiet corner of one galaxy, we are participants in this grand unfolding. We are made of the matter that resists the pull of gravity and lives within the reach of light,
but we exist in a universe governed by the unseen and the unexplained. Dark energy reminds us that reality extends far beyond what the eye can perceive, that the greatest forces at work in the cosmos are not those that roar, but those that whisper across the fabric of space and time. As the galaxies drift apart and the stars slowly dim, the universe continues its quiet expansion, a story still being written by forces we barely understand. The mystery of dark energy is not a source of fear, but of wonder. It tells us that the cosmos is alive in ways we have only begun to grasp, that creation did not end with the Big Bang, but continues, in silence, beneath the vast and unhurried pulse of eternity.
Chapter 15, The Truly Cosmic Horizon. There is a quiet comfort in knowing that the universe stretches far beyond what we can ever see. Even as we build larger telescopes, launch more powerful observatories, and study the faintest glimmers of ancient light, there remains a horizon we cannot cross, a boundary beyond which all sight, all contact, and all knowledge will forever fail. This is the cosmic event horizon, the edge of the observable universe and the outermost reach of light itself. It is not a wall, nor a physical barrier, but a threshold written into the geometry of space and time, a silent reminder that even the universe has limits that no effort can breach. When we speak of the observable universe, those 93 billion light-years in diameter, it sounds immense enough to contain everything that exists. Yet the word observable hides a profound truth. There is far more beyond it. The cosmos extends far past what light has had time to reach us since the Big Bang, and beyond that lies a deeper mystery. The expansion of space itself, driven by dark energy, is not slowing down, it is accelerating, stretching the distances between galaxies faster and faster, until some move away at a speed that no ray of light can overcome. Those galaxies are not merely hidden by distance, they are lost to us in principle. Their light will never arrive, not now, not in 1 trillion years. To imagine this, picture the universe not as a fixed space with objects drifting inside it, but as an ocean whose very water is expanding. Every drop moves apart as the sea grows. Now imagine that you are floating within it, and that some faraway islands are moving with the current faster than even a signal of light could swim back toward you. No matter how long you wait, the waves will never carry their image to your eyes. They are part of the same universe, but permanently beyond reach. This is not a poetic metaphor. It is the reality of cosmic expansion. The galaxies we observe at the edge of visibility are already crossing this point of no return. The light we see from them today is ancient, born billions of years ago when those galaxies were much closer. We are witnessing their past selves frozen in time. The light they emit now, in the present, is already doomed to drift endlessly into the expanding void, never to touch us. As we watch them twinkle faintly in our telescopes, we are in a very real sense watching them say goodbye. With each passing second, the universe's visible portion grows smaller in proportion to the whole. The number of galaxies that we can ever study or even detect decreases as cosmic acceleration carries them away faster than their light can travel. Eventually, all galaxies beyond our local group, the Milky Way and its neighbors, such as Andromeda and the Magellanic Clouds, will slip beyond this cosmic horizon. They will fade one by one, like distant ships sinking over an invisible curve of time. In the far future, the night sky will be a quieter place. The stars of our merged Milky Way and Andromeda galaxy will still shine, but beyond them, the universe will darken. The great web of galaxies that now fill our telescopes will vanish from sight, leaving behind an illusion of cosmic solitude.
Future astronomers, living trillions of years from now, will see no evidence that the universe ever extended beyond their local cluster. They will look up and find only the quiet glow of their own stars, unaware that once, long ago, the sky was alive with billions of galaxies blazing in every direction. This fate, sometimes called the Big Freeze, is not a collapse or a cataclysm, but a gradual drift into stillness. As galaxies recede and light stretches into longer and longer wavelengths, the cosmos grows colder, dimmer, and more silent. It is a story not of destruction, but of dispersal, an ever-expanding canvas whose paint has thinned almost to transparency. And yet there is something profoundly peaceful about this realization. The universe, in its vastness, is not confined to what we can know. It continues beyond us, unmeasured, unobserved, and untroubled by our limitations. Its enormity humbles the mind, but also soothes it, for it reminds us that our inability to see everything does not mean that nothing exists beyond it. The unseen majority of the cosmos continues its grand evolution, indifferent to our reach, and yet somehow inviting to our imagination. The cosmic horizon is not merely a boundary of vision, it is a meditation on perspective. It tells us that knowledge, like light, has a limit, and that beyond every discovery lies a greater mystery. The galaxies we will never see are still there, forming, colliding, shining, and fading, their stories unfolding in silence. The universe does not end where our understanding does. It simply becomes invisible, continuing its slow, eternal expansion into regions of time and space that no being will ever know. In that realization lies a gentle lesson, that we too exist within horizons. Our lives, our histories, and even our civilizations have boundaries we cannot cross. But beyond them, life continues, the universe endures, and creation unfolds in ways that need not be witnessed to be real. The cosmic event horizon is, in the end, not a wall, but a mirror. It reflects the limits of perception, the beauty of mystery, and the quiet assurance that the universe goes on, endlessly, serenely, and beyond the reach of light.
Part 4. A Universe of Dust and Rebirth. The universe is not still. It is alive with motion, decay, and renewal. Across the vastness of space, stars are born, live, and die, each one shaping the next generation in ways both violent and delicate. What seems like destruction is never the end. It is the beginning of something new. From the silent collapse of a dying star, to the soft rain of cosmic dust that settles upon our world each day, the cosmos is constantly recycling itself, turning endings into beginnings, ashes into light, and dust into life. This is the quiet rhythm of existence on a universal scale. The atoms that form our bodies were once trapped inside ancient suns. The same dust that drifts down from the sky tonight once glowed at the heart of a distant nebula. In the calm of night, as you listen and breathe, you are part of that endless exchange. The stories written in the stars are not far away. They live within you. In this chapter of our journey, we drift through the cycle of cosmic renewal, through stellar nurseries where new suns awaken, through the fiery deaths that scatter the elements of life, and into the tranquil showers of space dust that still fall upon the earth. It is a story of creation and return, a reminder that nothing in the universe is ever truly lost. Every ending becomes the seed of another beginning, and every grain of dust carries the memory of the stars. So as you close your eyes and let the story unfold, imagine the universe not as a distant spectacle, but as a vast, breathing organism, a place where even silence hums with creation, and where you too are made of starlight, continuing its long journey home.
Chapter 16. Stars are born in serene stellar nurseries. The story of a star's birth is one of patience and quiet transformation. It does not begin in fire or noise, but in silence, deep within the coldest, darkest corners of the galaxy. Here, in regions called molecular clouds, the building blocks of stars wait, drifting softly in the void. These clouds are vast beyond imagination, great veils of gas and dust stretching for hundreds of light years, floating in temperatures just a few degrees above absolute zero. To the human eye, they would appear almost invisible, but through infrared and radio telescopes, they glow faintly, revealing the hidden structures where new stars begin to form. Inside these clouds, the balance of the universe begins to shift. Gravity, the patient sculptor, starts its slow and steady work. Over millions of years, it gathers the faint, whispering threads of hydrogen and dust into thicker strands, then into clumps, and finally into dense knots of matter. It is an almost imperceptible process. No sound, no flash, no disturbance, just a gentle tightening of the cosmic fabric. As the clumps grow heavier, their gravity deepens, pulling in more of the surrounding material. Slowly, the temperature at their centers begins to rise. These growing knots are what astronomers call protostars, the unborn hearts of future suns. They are not yet hot enough to shine with true starlight. Instead, they glow faintly in infrared, cocooned in veils of dust that hide them from ordinary view. For ages, they continue to gather material, growing denser, warmer, and more luminous from within. Then one day, when the pressure and temperature in the core reach about 10 million degrees Celsius, the first sparks of nuclear fusion ignite. Hydrogen atoms begin to merge into helium, releasing light and heat that will burn steadily for billions of years. A new star has been born, not in chaos, but in quiet persistence. If you could see this process unfold, it would look like a slow blooming flower made of light. The surrounding gas begins to glow as the newborn star's radiation escapes its cocoon. Winds of charged particles sweep away the remaining dust, revealing the shining core that will one day host planets, asteroids, and perhaps, in the far future, life. The star's light, soft at first, gradually grows stronger, pushing against the darkness that birthed it. The pillars of creation in the Eagle Nebula offer us a glimpse into this celestial nursery.
These towering columns of gas and dust, each several light-years tall, resemble vast mountains floating in space. They stand serene and majestic, yet every inch of them is alive with hidden activity. Inside the pillars, gravity is at work, pulling dense pockets of gas together to form new stars. Around them, ultraviolet radiation from nearby young stars sculpts and erodes the structures, slowly wearing them down, like wind and rain shaping cliffs on Earth. What looks still and eternal is in truth a place of constant creation and change, a cosmic balance between destruction and birth. A similar beauty can be seen in the mystic mountain of the Carina Nebula, another vast cloud of gas and dust where stars are being born even as the region is torn apart by the forces of radiation and gravity. Jets of gas burst from newborn stars hidden within the cloud, carving channels through the surrounding material. Meanwhile, fierce winds from massive, luminous stars nearby push against the outer edges, shaping the mountain into peaks and valleys that shimmer in hues of blue and gold. Though these events unfold over millennia, to the universe they are brief moments, tiny ripples in a much greater tide of creation. Despite the immense forces at play, the birth of a star remains a gentle act in cosmic terms. It is the universe gathering itself, concentrating its own essence into a new point of light. Every star we see in the night sky was once part of such a cloud, a handful of atoms drawn together by gravity's quiet insistence. Even our own sun was once a glowing embryo inside a long-vanished nebula, surrounded by dust that would later form the planets of the solar system. Every breath we take, every atom in our bodies carries the memory of that beginning, forged from the same cold hydrogen that once floated between the stars. When we look at images of these stellar nurseries, whether the misty arches of the Eagle Nebula or the sculpted peaks of Carina, it's easy to forget that we are looking across time. The light that reaches us left those clouds thousands of years ago, carrying the ancient story of creation written in photons. It is a story of patience, delicacy, and balance, a story that repeats endlessly across the galaxy. In the end, the birth of a star is a reminder that the universe does not rush. It builds slowly, gracefully, through forces that seem gentle but are immense beyond measure. Every sunrise we witness began in such stillness. Every glimmer in the sky was once a quiet gathering of dust and darkness. And as we gaze upward tonight, those serene clouds are still at work, hidden in the depths of space, preparing the next generation of stars that will one day illuminate the future of the cosmos.
Chapter 17. The elements of life are forged in the hearts of stars.
Every star that burns in the night sky is not only a beacon of light, but a quiet laboratory of creation. Inside its glowing core, matter itself is being transformed. For billions of years, a star like our sun maintains a delicate balance, pressing inward under the immense weight of gravity, while pushing outward with the steady energy of nuclear fusion. In that balance lies the calm rhythm of stellar life, a rhythm that has shaped the chemistry of the cosmos. At the heart of the star, hydrogen, the simplest and most abundant element in the universe, is constantly being joined together to form helium. This is not a violent clash, but a process of immense grace. Each fusion releases a tiny burst of energy, and together these countless fusions produce the gentle brilliance that warms worlds and lights the darkness of space. The same process that makes the sun rise each morning is quietly transforming the raw material of the early universe into something more complex, more capable of giving rise to life. But stars do not stay young forever. As they age, their inner furnaces grow more intricate. In stars more massive than the sun, gravity and temperature work together to open new pathways of creation. When the supply of hydrogen in the core begins to dwindle, the star contracts under its own weight. This compression raises the temperature further, igniting new forms of fusion. Helium atoms begin to fuse into carbon, carbon into oxygen, oxygen into silicon, and so on, layer upon layer, as if the star were building a cosmic onion of energy and matter. Each shell around the core represents a new stage of alchemy. The deeper layers burn faster and hotter, while the outer layers continue their slower transformations. Within these concentric rings, the universe manufactures the ingredients that will one day make up planets, oceans, forests, and the living cells of creatures yet to be born. For millions of years, these stars live out their lives as cosmic forges, quietly shaping the periodic table one element at a time. But there is a limit to how far this process can go. When the fusion reaches iron, something profound happens. Iron is the cosmic boundary between creation and collapse. Unlike lighter elements, fusing iron does not release energy, it consumes it. In that moment, the delicate balance that has kept the star alive begins to falter. The outward pressure from fusion weakens, and gravity, which has been waiting patiently for billions of years, takes over. The core collapses in an instant, imploding under its own immense weight. What follows is one of the most powerful events in the universe, a supernova. In the blink of an eye, the collapsing core rebounds, sending shock waves through the star's outer layers. For a few moments, the dying star shines brighter than all the galaxies in its vicinity combined. And in that brief, fiery farewell, something extraordinary happens. The extreme heat and pressure of the explosion create conditions that even the most massive stars could never achieve in their lifetimes. In those fleeting seconds, the universe gives birth to all the elements heavier than iron: gold, silver, platinum, uranium, and countless others. These elements, forged in chaos, will one day become the material for worlds and for life itself. As the explosion subsides, the star's remains are scattered into space. The atoms it created drift outward, carried on expanding waves of dust and light. Over millions of years, they mix with interstellar gas, seeding new clouds from which future stars and planets will form. This cycle of creation and destruction repeats endlessly. Stars are born, live, die, and from their ashes, new stars arise. The galaxy is, in this sense, a vast ecosystem of matter, always renewing itself through the lives and deaths of its suns. Every molecule in our bodies tells this same story. The calcium in our bones was forged in a long-dead star. The iron that carries oxygen through our blood once shimmered in the core of a red giant. The oxygen we breathe was first born in a stellar nursery, and the carbon that forms the structure of our DNA was created in the heart of a dying sun. We are literally made of the debris of ancient stars. When you look up at the night sky, you are seeing not only the future of light, but also the past of your own being. This idea that the elements of life come from stars is one of the most beautiful insights of modern science. It reveals an intimate connection between the human story and the story of the cosmos. We are not separate from the universe. We are part of its unfolding. Our bodies are temporary arrangements of ancient stardust, held together for a moment in time before returning to the same cosmic cycle that has shaped everything from the smallest grain of sand to the largest galaxy cluster. In the quiet glow of the night sky, this truth takes on a comforting simplicity. Each star we see is both a mirror and a promise. A mirror reflecting our origins, and a promise that the universe, though vast and cold, is not indifferent. It is creative, patient, and generous. It took billions of years of stellar births and deaths to make the world we inhabit, to give rise to the air we breathe, and to allow a species of stardust to gaze back at the heavens and wonder. To know that we are made of stars is not a metaphor. It is a fact written in every atom of our being. The universe has spent eons preparing the ingredients for life, scattering them gently through space, waiting for the right moment to combine them in the form of consciousness. And so, as we drift beneath the stars tonight, it is worth remembering that we are, in every sense, the universe looking back at itself.
Chapter 18. A supernova can outshine its entire galaxy. There are few events in the cosmos as breathtaking or as transformative as the death of a massive star. For millions of years, such a star shines steadily, balancing two opposing forces: the outward pressure of fusion at its core and the inward pull of its own gravity. This delicate harmony is what allows the star to exist. But like all living things, even stars have lifespans. Eventually, the fuel that sustains their brilliance begins to run out. When that happens, the balance collapses. The fusion that once held the star's core stable fades, and gravity, ever patient, ever persistent, takes control. The entire core caves inwards in a fraction of a second, an implosion of unimaginable power. The outer layers, unable to resist, crash downward and then rebound violently in a cataclysmic eruption. In that moment, the star dies, but its death releases more light than all the billions of stars around it combined. This is a supernova, the grand finale of stellar life, the instant when destruction becomes creation. For a brief span, perhaps a few days or weeks, a single dying star can illuminate the entire galaxy it belongs to. Its light can travel millions of light years through the darkness, crossing the intergalactic void, to reach eyes that may one day gaze at it from a small planet far away. The energy released in this single explosion is staggering. In those fleeting moments, the supernova radiates as much power as our sun will emit over its entire 10 billion-year lifetime. Human history has witnessed this phenomenon. In the year 1054, observers in China, Japan, and the Middle East recorded the sudden appearance of a guest star in the constellation Taurus. It was so bright that it could be seen in broad daylight for almost a month, and it glowed in the night sky for nearly 2 years before fading from view. What they witnessed was a massive star's death, the event that created what we now know as the Crab Nebula, a beautiful and expanding cloud of gas and dust still racing outward through space nearly 1,000 years later. To the unaided eye, it was a moment of wonder and mystery, but to the universe it was an act of renewal. The explosion was not just light and heat, it was a dispersal, a scattering of life's future ingredients. The heavy elements forged deep in the heart of the star during its lifetime, carbon, oxygen, silicon, and iron, were hurled outwards at speeds of thousands of kilometers per second. These atoms, now free, mixed with interstellar gas and dust, enriching the galaxy. They would later become part of new stars, new planets, and even, much later, living beings. The atoms of your body, the iron in your blood, the oxygen you breathe, the calcium in your bones, were once flung across space in a storm of light and radiation from such an explosion. It is a humbling thought. The most precious materials in the universe were born in its most violent moments. But not all of the star is lost in the blast. Deep in its center, what remains undergoes a transformation so extreme that it almost defies imagination. In some cases, the collapsing core compresses into a neutron star, a city-sized sphere of pure atomic matter so dense that a teaspoon of it would weigh billions of tons. In other cases, the collapse continues without end, creating a black hole, a region where gravity is so absolute that even light itself cannot escape. These remnants, though invisible, are not silent. Neutron stars spin rapidly, sending out pulses of radiation like cosmic lighthouses. Black holes warp the space around them, shaping the motion of nearby stars and gas for millions of years. And yet, even in their destruction, the dying stars leave behind a legacy of beauty. The material cast off from the supernova expands outward into intricate clouds that glow with color and light. Some appear as ghostly rings, others as tangled filaments spreading across space. The gases shimmer with different hues depending on the elements they contain. Oxygen glows green, hydrogen shines red, sulfur burns faintly blue. Over time, these nebulae become vast stellar nurseries, where gravity gathers the scattered dust once again into new forms. In this way, the death of one generation of stars gives rise to the next. Supernovae are also the universe's alchemists. Within their explosions, new elements are forged, those heavier than iron, which no star can create in its normal life. Gold, silver, platinum, and uranium come into being only in these brief, furious instants of stellar death. Each atom of gold that exists, whether resting in the Earth's crust or adorning a human hand, was once part of the blinding detonation of a long-gone star. It is a humbling thought. The most precious materials in the universe were born in its most violent moments. And yet, there is a deep serenity in this cosmic cycle. The universe wastes nothing. Every end becomes a beginning.
the atoms cast out by one supernova drift for millions of years through the galactic sea, joining others, collecting dust, forming new clouds, and eventually coalescing again into new suns. Around those suns, planets will form, some rocky, some icy, some cloaked in oceans or air. On one such world, orbiting an unremarkable star, those atoms would come together as life, and that life would one day look up and wonder about the stars. So the story of a supernova is not a story of death, but of continuity. It is the universe breathing, exhaling matter into the darkness, so that somewhere light may one day rise again. When we look up at the night sky, each star we see carries within it the potential for both endings and beginnings. And somewhere, in the quiet depths of space, a star may even now be preparing for its final act, an explosion so bright that it will momentarily rival an entire galaxy, spreading its gift of elements across the void, ensuring that the cycle of light and life continues. In this cosmic rhythm of collapse and renewal, we find a reflection of our own existence. Just as stars must die to create the ingredients for new worlds, so too does every ending in nature give rise to something new. The universe is not static. It is a living, evolving masterpiece, one that transforms even destruction into creation, even silence into radiance.
And in the calm light of that truth, we can find a quiet sense of belonging. We too are part of that endless cycle, born from the ashes of ancient stars, destined to shine, if only for a little while, before returning our atoms to the vast, patient cosmos that made us.
Chapter 19. We are made of star stuff.
Every element that makes up our world, every atom in our bodies, carries a story that began long before the Earth was born. The universe, vast and ancient, has spent billions of years creating the materials that would one day become us. When we say that we are made of star stuff, it is not poetry. It is a literal truth written in the language of physics and chemistry. The calcium in our bones, the iron in our blood, the oxygen that fills our lungs, and the carbon that forms the backbone of life's molecules, all of these were forged in the hearts of stars that lived, shone, and died long before our planet even existed. In the beginning, the universe was simple. After the Big Bang, it was filled mostly with hydrogen and helium, the lightest elements born in the first few minutes of cosmic time. There were no heavy elements then, no carbon or oxygen, no silicon or iron. The first stars, enormous and short-lived, were built entirely from this primordial gas. They were the first forges of creation. In their fiery cores, nuclear fusion began to build new elements, slowly climbing the ladder from hydrogen to helium, to carbon, to oxygen, and beyond. When these massive stars reached the end of their lives, they died in spectacular supernova explosions, hurling their enriched contents into space. Those explosions seeded the galaxy with the ingredients of complexity. Out of their ashes, new clouds of gas and dust began to form, now laced with the heavy elements the first stars had created. From these enriched clouds, new generations of stars and planets emerged, more complex, more capable of supporting life. Our own solar system is one of these second-generation creations. Around 4.6 billion years ago, in a quiet corner of the Milky Way, a cloud of interstellar gas began to collapse under the pull of gravity. At its center, a young sun began to shine, while around it, the leftover dust and gas coalesced into planets, moons, and countless smaller bodies. Every grain of rock, every drop of water, every cell that would one day exist on Earth came from the remains of those ancient, vanished stars. When we look up at the night sky, we are not gazing into an unfamiliar realm. We are looking into our own history. The light that reaches us from distant stars carries not just beauty, but memory. The memory of the processes that made life possible. The carbon that shapes the delicate structure of a leaf, the nitrogen that fills the air, and the iron that strengthens our planet's core, all share a common origin in those stellar furnaces. Every part of us, from the smallest cell to the heaviest bone, is composed of atoms once scattered across space, drifting through the dark for millions of years before finding their place in a living world. The story of our bodies is also the story of cosmic recycling. The universe has been doing this for billions of years, building stars, letting them live, watching them die, and then using their remnants to create something new. It is a slow, patient process that spans unimaginable time, yet it has led from the simplest atoms to the emergence of consciousness. The same carbon atom that once glowed inside a red giant might now form part of a tree, or a human being, or a breath of air. In time, it will move on again, perhaps to become part of another planet, or another living creature in some distant age. When astronomers analyze the sun, they find proof of this inheritance. It is not made only of the original hydrogen and helium from the early universe. It contains heavier elements, carbon, oxygen, silicon, iron, that could only have been made by earlier generations of stars. Our solar system, then, is a child of starlight and death, a product of cosmic evolution written in the language of chemistry. Without those earlier suns, there would be no Earth, no oceans, no mountains, and no life. The elements that make up the world are not accidents, they are the legacy of the stars. The same is true of us. The iron in our blood once pulsed within the heart of a star. The oxygen we breathe was released by another star's final breath. Even the water we drink contains hydrogen atoms formed in the first seconds after the Big Bang. When we realize this, the boundary between ourselves and the universe dissolves. We are not outsiders looking in. We are part of the unfolding story of the cosmos itself. The atoms that compose us have passed through countless forms: dust, flame, ocean, living being, and they will continue their journey long after we are gone. This understanding can bring a deep sense of peace. It reminds us that we belong here, in this vast and beautiful universe. We are not small in a way that diminishes us. We are small in a way that connects us to everything. The same physical laws that shaped galaxies
also shaped the cells in our bodies. The same cosmic forces that forged the stars are still at work within us, binding our atoms together, allowing us to think, to dream, and to wonder about where we came from. When Carl Sagan said, "We are made of star stuff," he was giving voice to one of the most extraordinary discoveries in science, that life is not separate from the universe, but an expression of it. The universe does not simply surround us, it flows through us. Every heartbeat, every breath, every thought is part of a chain of events that began in the birth of the stars. To look up at the night sky is to look at our own reflection, written in light and distance. And so, when we gaze into the quiet darkness of space, we can take comfort in knowing that the story of the stars is also our story. We are the universe made conscious, a collection of atoms that can, for a fleeting moment, marvel at its own existence. The stars are not strangers to us. They are our ancestors, our kin, our origin, and our destiny. In their light, we find not only beauty, but belonging.
Chapter 20. Teaspoons of Stardom. There are places in the universe so dense, so extreme, that even imagination struggles to grasp them. When a massive star dies, its death leaves behind one of nature's most extraordinary creations. A remnant that compresses more mass than our sun into a sphere smaller than a city. These remnants, called neutron stars, are among the strangest objects in existence. The material within them is packed so tightly that a single teaspoon would weigh as much as a mountain range. It is an idea that defies intuition, yet it is real, confirmed by observation and physics. These stellar ghosts remind us how gentle our corner of the cosmos truly is, how peaceful Earth feels compared to the violent heart of the universe from which it was born. When a star, many times larger than our sun, reaches the end of its life, it exhausts the nuclear fuel that has kept it shining for millions of years. With fusion no longer producing outward pressure, gravity takes over. The entire core of the star collapses inward, squeezing atoms to their very limits. The electrons that once orbited atomic nuclei are crushed into the protons they encircle, fusing into neutrons. The result is an object composed almost entirely of these neutral particles, an immense ball of pure nuclear matter. It is as if the core of an atomic nucleus, usually smaller than the width of a hair, has been expanded to the size of a city. In that moment, all the empty space that makes up ordinary matter, space that accounts for nearly all of an atom's volume, is gone. What remains is the densest form of matter that can exist without collapsing into something even stranger. The numbers describing these stars are almost beyond belief. A typical neutron star contains about 1.5 times the mass of our sun, but measures only 20 kilometers across. Its surface gravity is so strong that if you were to drop a paperclip onto it, it would hit the surface at a fraction of the speed of light, releasing more energy than the most powerful bombs ever created. A teaspoon of neutron star material, brought somehow to Earth, would weigh billions of tons, more than Mount Everest. Yet despite such ferocity, these stars are not chaotic. They are precise, structured, and astonishingly stable, spinning hundreds of times per second and glowing faintly with the heat of their birth. Some neutron stars reveal themselves through their rotation. As they spin, their enormous magnetic fields, trillions times stronger than Earth's, channel streams of energy out from their magnetic poles.
These beams sweep across space like the rays of a cosmic lighthouse. When one of these beams happens to point toward Earth, astronomers detect a pulse of radiation with each rotation. To us, it looks like a blinking star, flashing with astonishing regularity, sometimes hundreds of times per second. These objects are called pulsars, and they are so precise that their timing can rival the accuracy of atomic clocks. The first pulsar was discovered in 1967, and at first it was so regular that scientists wondered if it might be an artificial signal. But it was not a message, it was the heartbeat of a dead star, echoing through the cosmos. Yet even neutron stars have their limits. When a dying star is too massive, more than about 3 times the mass of our Sun, not even the pressure from packed neutrons can resist the pull of gravity. The collapse continues, unstoppable. The star implodes completely, crushing itself into something smaller than a grain of dust, something that defies all known laws of physics. This is the birth of a black hole. A black hole is not a solid object in the way we understand matter. It is a region of space where gravity has become absolute. Everything that crosses a certain invisible boundary, called the event horizon, is trapped forever. Not even light, the fastest thing in the universe, can escape. To the outside observer, this boundary marks the edge of a shadow, a place where space and time themselves are warped beyond recognition. Inside, the core collapses to what physics calls a singularity, a point of infinite density and zero volume. In that singularity, our equations fail. The familiar rules that describe planets, stars, and galaxies no longer apply. Time and space, as we know them, cease to have meaning. Yet these objects, terrifying as they sound, are not monsters roaming the cosmos. They are quiet, patient remnants, relics of stars that once illuminated the night. Black holes do not roam through space, devouring everything in their path. They obey the same gravitational laws as any other massive object. If our Sun were replaced by a black hole of equal mass, Earth's orbit would remain unchanged. We would simply be circling an invisible point of darkness instead of a glowing sphere. Their power lies not in aggression, but in their very nature, the extreme curvature of space-time that defines them. Around some black holes, however, the environment becomes spectacular. As gas and dust fall toward the event horizon, they spiral inward, forming a brilliant, spinning disk. The friction and compression in this disk heat it to astonishing temperatures, causing it to shine with a brilliance that can outshine entire galaxies. In this way, even the darkest objects in the universe can create some of its brightest light. Neutron stars and black holes may seem like exotic curiosities, far removed from human experience, yet in truth, they are the natural outcome of the same laws that govern our world. The same gravity that holds us to Earth is what crushes stars into these extreme forms. The same atomic forces that bind the matter in our bodies are those that fail under the unimaginable pressures of a collapsing core. By studying these strange remnants, scientists glimpse the limits of reality itself, where matter, energy, and space become indistinguishable. And there is something deeply calming in this realization. The universe contains regions of unimaginable violence and density, yet here we are, living in the quiet aftermath. The atoms in our bodies were once part of that chaos, forged in the fiery deaths of ancient stars, but they now exist in a world of gentle light, breathable air, and soft gravity. We are surrounded by calmness because the universe has already endured its storms. When we gaze into the night sky and imagine those distant neutron stars spinning in silence, or the black holes hidden in the centers of galaxies, we are not looking at danger, but at balance.
These remnants are reminders of what the universe can do and what it has already done. They are the punctuation marks at the end of stellar lives, the points where matter yields to mystery. To know that such extremes exist, to understand that a teaspoon of matter can outweigh mountains, or that space itself can fold into darkness, is to glimpse the breadth of creation. Yet rather than fear, it brings perspective. We live in a rare and peaceful moment, on a planet warmed by a stable star, cushioned between the inferno of stellar birth and the abyss of stellar death. The universe around us is vast and wild, but it is also exquisitely ordered, allowing the fragile beauty of life to exist in its quiet corners. We are, in every sense, the children of that balance, descendants of the stars that once burned, collapsed, and gave everything they had to the cosmos. In their deaths, they created the materials that would one day become us. In their silence, they continue to remind us of the wonder of existence itself.
Chapter 21. Every day, Earth is showered in cosmic dust. Every moment of every day, the Earth is quietly visited by the cosmos. From every direction, tiny fragments of distant worlds descend upon our planet, drifting down through the air until they rest on oceans, mountains, rooftops, and even on your skin. They are the remnants of comets and asteroids, the ancient leftovers from the time when the solar system was still young. Scientists estimate that about 14 tons of this material settles onto Earth's surface every day, a steady, silent snowfall of space dust that never truly stops. It is strange to think that something so immense, so vast as the solar system, reaches into our everyday lives in this gentle way. The dust that lands on your windowsill tonight may have formed billions of years ago, when the sun was still wrapped in a swirling disk of gas and debris. It may have spent eons drifting through the outer reaches of the solar system, orbiting among the icy remnants beyond Jupiter, before its path was nudged inward by gravity. Now, at the end of its long journey, it becomes part of our world. Most of these particles are so small that we never notice them. They are no larger than a grain of sand, yet they arrive at astonishing speeds, sometimes more than 50,000 kilometers per hour. As they enter Earth's atmosphere, friction with the air heats them to thousands of degrees. For a brief instant, each grain becomes a point of light streaking across the sky, a meteor. It is one of the few times we can actually see cosmic dust, burning up as it races towards us. But only the largest particles leave visible trails. The vast majority of this cosmic rain arrives invisibly, melting into droplets high in the atmosphere before cooling, slowing, and gently drifting down through the air like invisible snow. When these droplets harden, they form tiny spherical beads of rock and metal, known as cosmic spherules. Under a microscope, they glint like jewels, perfect glassy spheres, sometimes with swirling metallic interiors or subtle colors that hint at their mineral content. Scientists find them everywhere, in deep-sea sediments, in ancient rocks, even on city rooftops. If you were to take a magnet and run it through the dust that collects in your gutter after a rain, you might pull out one of these little black spheres from space without even realizing it. To study these cosmic visitors more precisely, scientists traveled to one of the purest places on Earth, Antarctica. There, far from pollution and the dust of human activity, they collect clean snow and ice, melt it, and filter it grain by grain. What they find is astonishing. Each sample of Antarctic snow contains tiny fragments from comets and asteroids, micrometeorites perfectly preserved by the cold. Decades of careful research in these frozen landscapes have revealed that the Earth receives over 5,000 tons of cosmic material every year, and roughly 80% of it comes from Jupiter family comets, ancient bodies that orbit the Sun in long, looping paths, shedding dust and fragments as they are gently heated by sunlight. Every particle tells a story. Some contain minerals formed in the deep interiors of asteroids, rocks that once experienced heat and pressure during violent collisions billions of years ago. Others carry traces of organic compounds, simple carbon-based molecules that may have played a role in life's beginnings on Earth. Each grain is a messenger from a different corner of the solar system, and when we collect them, we are literally gathering the history of our cosmic neighborhood. If you were to hold one of these specks in your hand, it would appear utterly ordinary, a dark fleck of dust, no different from the soil beneath your feet. But in reality, it has traveled from millions, even billions of years to reach you. It may have originated in the cold outer reaches beyond Neptune, or from the shattered remains of an asteroid between Mars and Jupiter. It may have wandered through interplanetary space, circling the Sun countless times, before finally intersecting Earth's orbit, drawn by our planet's gravity. By the time it touches the surface, its journey has spanned more time than all of human history combined. When seen this way, the sky above us no longer feels distant. The boundary between Earth and space becomes less clear, more porous. Our atmosphere is not a sealed dome, but a soft veil through which the universe continually passes, sharing its material with us. The oceans, the soil, even our bodies contain atoms that once drifted freely through space. The cosmic and the earthly are not separate realms. They are parts of one continuous story. The next time you look at a starry night, remember that the space between those stars is not empty. It is filled with the same dust that now rests quietly on your window pane or floats unseen in the air you breathe. We are surrounded by the material of the cosmos, not just metaphorically, but physically. The universe is always reaching out, always touching us in the smallest of ways. This daily rain of cosmic dust is a reminder that we live in the midst of something vast and ongoing. We are part of a solar system still in motion, still exchanging matter between its worlds. The remnants of ancient comets and shattered asteroids continue to fall upon us, linking our small blue planet to the endless expanse beyond. It is a humbling thought, and a comforting one. The cosmos does not end where our atmosphere begins. Every day, without our noticing, it comes to visit us. It settles softly on the mountaintops, on the oceans, on the leaves of trees, and on our skin. It whispers, in its silent fall, that we have never been alone. We are part of an unbroken exchange between Earth and the universe, an eternal conversation written in dust.
Part 5. Echoes of the Beginning.
The final part of our journey leads us back to the dawn of everything, to the first light that ever shone across the newborn universe. In this quiet exploration, We listen to the ancient echo that still hums through space, the faint afterglow of the Big Bang itself. It is a whisper from a time when all matter, energy, and light were one, when the cosmos was young, bright, and impossibly hot. As the story unfolds, we will trace how that brilliance faded into calm, how the blinding fog of creation slowly became clear, and how tiny ripples in that early glow grew into galaxies, stars, and worlds. We will follow the universe as it expands and cools, from its fiery beginnings to the tranquil, starlit silence we know today. This is a meditation on origin and change, on how everything, including us, arose from light. By tuning in to the universe's oldest memory, we find not only a scientific story, but a soothing reminder of connection, that across time and distance, all things still carry the same ancient warmth, the same gentle pulse of creation.
Chapter 22. The Oldest Light in the Universe. When we gaze into the deep night sky, past the shimmer of stars and the faint glow of distant galaxies, we are not only looking into space, we are looking into time. Beyond every star and cluster lies a faint, invisible ocean of light, older than any star, older than any galaxy, older even than the atoms that make up our bodies. This is the cosmic microwave background, or CMB, the soft afterglow of creation itself. It is the oldest light we can ever hope to see, a quiet whisper from the universe's fiery beginning nearly 13.8 billion years ago. This light, though invisible to our eyes, fills the cosmos completely. It is everywhere, bathing every corner of the universe in a faint warmth of just 2.7 degrees above absolute zero. If we could tune our senses to microwaves instead of visible light, the entire sky would glow with an even, ghostly brightness. It does not come from stars or planets. It comes from the very fabric of space itself, from a time when the entire universe was a dense, hot fog of matter and radiation. For hundreds of thousands of years after the Big Bang, the cosmos was a blinding plasma, where particles of light, or photons, were constantly scattered by electrons. The universe was opaque. Light could not travel freely. But as the universe expanded, it cooled. Around 380,000 years after the beginning, the temperature finally dropped low enough for electrons and protons to combine into neutral hydrogen atoms. At that moment, light was released and could move freely through space for the first time. What we see today as the cosmic microwave background is that very light, the first light that ever shone freely. Its discovery, like many great moments in science, was unexpected. In 1964, two engineers, Arno Penzias and Robert Wilson, were testing a large horn-shaped antenna at Bell Laboratories in New Jersey. They were frustrated by a persistent, faint noise that refused to disappear, no matter how carefully they cleaned or adjusted their equipment. They even removed what they called white dielectric material, pigeon droppings, from inside the antenna
thinking it might be the cause. Yet the noise remained constant, coming from every direction at once. What they had stumbled upon, quite by accident, was the ancient light of the universe itself. At the same time, a team at Princeton University, led by Robert Dick, was preparing to search for exactly such a signal, predicted years earlier by cosmologists who believed the universe began in a hot, dense state. When Penzias and Wilson learned of this, the two groups realized the extraordinary truth. The faint static in their radio telescope was the leftover heat from the Big Bang. For their discovery, Penzias and Wilson were later awarded the Nobel Prize in Physics, and the CMB became one of the most important pieces of evidence supporting the Big Bang theory. The cosmic microwave background is not perfectly uniform. Its temperature varies slightly by only 1 part in 100,000. But these minuscule ripples are the seeds from which all cosmic structures grew. In places where the radiation was just a tiny bit denser, gravity slowly gathered matter together. Over billions of years, those small differences became vast webs of galaxies, stars, planets, and eventually life. In this way, the faint variations in the CMB contain the blueprint for everything that exists today. Satellites such as COBE, WMAP, and Planck have mapped this ancient light in exquisite detail, turning the sky into a cosmic tapestry of blues and reds that represent temperature differences of mere millionths of a degree. From these maps, scientists have been able to measure the age of the universe, its rate of expansion, and even its composition. About 5% of the universe consists of ordinary matter, the kind that makes up stars, planets, and people. The rest is made of invisible substances, roughly 27% dark matter and 68% dark energy, mysterious forces that shape the cosmos yet remain beyond our direct detection. And so, when we think of the cosmic microwave background, we can think of it as the universe's first memory, light that has been traveling for nearly 14 billion years, unchanged, carrying the story of creation itself. It connects us not just to the distant stars, but to the very moment when space and time were born. Every photon of that ancient light has crossed the unimaginable distances between galaxies, drifting silently through cosmic darkness, until some of it reaches our instruments here on Earth. As you listen to these words and imagine that primordial glow, you are hearing the echo of a time when everything we know, every atom, every mountain, every heartbeat was still one. The oldest light in the universe is not only a relic of physics, it is also a quiet reminder that all things, no matter how distant or different, share a single origin. The same light that once filled the newborn universe still passes gently through you tonight.
Chapter 23. From Fog to Transparency.
In the beginning, the universe was not the vast star-studded expanse we see today. It was dense beyond imagination, filled with light that could not escape. Every particle, every photon, every atom that would one day make up galaxies, stars, and living beings was pressed together in an ocean of searing brightness. Temperatures were so high that ordinary atoms could not exist. Electrons were torn from protons, and matter was locked in a turbulent dance of energy. The young universe was a blinding fog of light and particles, radiant yet utterly opaque. If we could somehow stand within that ancient glow, we would not have seen darkness or space as we know it now. We would have been surrounded by an endless, incandescent mist glowing at about 3,000 Kelvin, roughly as hot as the surface of a red giant star. The light would have been fierce, a deep orange radiance flooding every direction. Yet paradoxically, nothing could truly be seen. Photons, the particles of light, were trapped, constantly colliding with free electrons that scattered them in all directions. Like headlights swallowed by a thick cloud, every beam was instantly diffused. The universe shone with an almost unbearable brilliance, but it was a brilliance without vision, a light without distance. This was the age of plasma, a time before atoms. Gravity tried to gather matter into denser clumps, while the pressure from trapped radiation pushed back, creating an immense struggle that rippled through the cosmic fog. Those ripples were, in fact, enormous sound waves, vibrations traveling through the plasma of the young universe. They surged and resonated, compressing and expanding the primordial gas. The universe in its infancy was literally ringing with sound, though not sound we could ever hear. Its notes were measured in wavelengths of hundreds of thousands of light-years, a slow, deep hum, what scientists now call the acoustic oscillations of the early cosmos. These pressure waves left faint imprints that still exist today. When scientists study the tiny variations in the cosmic microwave background, they are, in fact, observing the frozen echoes of those ancient harmonies. Each ripple in that map of light is a silent chord from the universe's first music, a record of the push and pull between matter and light in those first 380,000 years. But as the universe continued to expand, it began to cool. Gradually, the temperature dropped from billions of degrees to just a few thousand. At around 3,000 Kelvin, a transformation occurred that would forever change the cosmos. Free electrons, once too energetic to remain bound, slowed down enough to be captured by protons, forming the first neutral atoms of hydrogen. For the first time, light was no longer trapped. It could move freely, unscattered, across the vastness of space. The fog cleared, and the universe became transparent. This great transition is known as recombination, though the name is somewhat misleading. It was not truly a recombination, since electrons and protons had never been combined before. It was the first time that matter as we know it could exist in stable form. The term came from earlier atomic physics, and though inaccurate, became part of the language of cosmology. What mattered most was the result, the birth of transparency, the moment light could finally roam the cosmos. This transformation happened astonishingly fast by cosmic standards. It was as if a vast veil had been lifted from the face of the universe. One moment, photons were ricocheting endlessly through the plasma. The next, they were free, sailing through expanding space. The light released in that instant, the light of the first dawn, still surrounds us today as the cosmic microwave background. Every photon of that glow has been traveling for nearly 13.8 billion years, stretched and softened by the expanding fabric of space. When it began, this light was a fiery orange glow at 3,000 degrees. Over billions of years, as the universe expanded and cooled, the light's wavelength stretched, shifting from visible to infrared
and eventually into the faint microwave range. What was once a dazzling radiance now bathes the cosmos as a cold, uniform glow at just 2.7 Kelvin, barely above absolute zero. Yet it still fills all of space, a quiet reminder of that first clearing, when the fog of creation lifted and the cosmos revealed itself for the first time. Through telescopes and satellites like COBE, MWAP, and Planck, we can capture the faint trace of that moment, the oldest light in existence. Its pattern is not perfectly smooth. It carries within it delicate ripples, the fingerprints of the sound waves that once rolled through the plasma. From these subtle differences, scientists can read the story of the universe's birth, its density, its age, its composition, and the very geometry of space itself. When we look at this light, we are seeing the universe as it was just 380,000 years after its beginning. Beyond that, no light can reach us, for before recombination, the universe was opaque. That luminous fog marks the limit of our vision, the edge of what we can ever observe directly. Yet it also marks the beginning of everything familiar, the formation of atoms, the slow gathering of gas into clouds, the birth of the first stars and galaxies. The cosmic microwave background is therefore not just ancient light, it is the universe's first memory. It tells of a time when creation was still glowing, when all matter was part of a single, radiant mist. The photons that fill our instruments today have crossed the entire history of existence to reach us, carrying within them the signature of that transition, from fog to transparency, from chaos to clarity, from the fiery infancy of the cosmos to the silent, star-filled night that now surrounds us. And as we contemplate this faint, ancient light, we can feel a quiet connection to that distant age. Every atom in our bodies was once part of that same luminous sea. The transparency that began then made it possible for the universe to see itself, for stars to shine, for planets to form, for life to one day look back into the darkness and find meaning in the light.
Chapter 24. The universe's temperature is 2.7 Kelvin. Across the boundless expanse of the cosmos, far beyond the warmth of any star, there exists a constant, quiet temperature, a faint thermal whisper that fills all of space. It is the afterglow of the Big Bang, now cooled and stretched by nearly 14 billion years of cosmic expansion. This ancient light, known as the cosmic microwave background, was once a brilliant radiance at about 3,000 Kelvin, glowing with the brightness of molten metal. But today, that same light has cooled to a mere 2.725 Kelvin, only a few degrees above absolute zero. It is the soft, invisible warmth that lingers everywhere, even in the emptiest regions between galaxies. To understand how cold this truly is, we must first imagine the meaning of absolute zero, the lowest possible temperature in nature. At 0 Kelvin, equivalent to minus 273.15 degrees Celsius, all atomic motion would, in theory, cease entirely. The universe would be utterly still. The background temperature of 2.7 Kelvin is only a fraction above that ultimate stillness. It is the natural temperature of deep space, the baseline heat of existence itself. Wherever you go, no matter how far from a star or galaxy, you are bathed in this faint, ancient glow. It is the quiet breath of a universe that began in fire and now rests in near perfect calm. Long ago, when the cosmic microwave background was first released, the universe was a sea of light, glowing orange and white, hot enough to melt iron. As the universe expanded, the very fabric of space stretched, and with it the wavelengths of that light. Like ripples on an ever-growing pond, the photons of the early cosmos were pulled farther and farther apart. Their energy weakened, their color shifted, and what was once fiery visible light became the gentle hum of microwaves we detect today. This cooling was not caused by loss of heat to any surrounding void. Rather, it was the direct result of space itself expanding, carrying the ancient light outward across time. One of the most astonishing aspects of this discovery is that it can be measured, and in a way, even seen. If you ever watched an old analog television and turned to an empty channel, the random static that filled the screen contained a faint trace of this very radiation. Among the white snow of electronic noise, about 1% of it came from the cosmic microwave background. Without realizing it, countless people once witnessed the afterglow of creation flickering across their television screens, a remnant of an event that took place nearly 14 billion years ago. Scientists have measured this temperature with extraordinary precision, 2.725 Kelvin to be exact. This number is not arbitrary. It defines the thermal landscape of the entire universe. It is the temperature of the cosmic ocean in which all galaxies float. If you could somehow drift between stars, leaving behind every planet and every sun, you would not find the temperature falling endlessly toward zero. Instead, you would find yourself immersed in a faint microwave glow, its photons brushing against you from every direction. This is the baseline of the cosmos, the quiet equilibrium that fills every cubic meter of space. This universal temperature serves as a kind of cosmic clock. By studying it, scientists can tell how much the universe has stretched since its birth. When the light was first released, its temperature was about 3,000 Kelvin, roughly the color of a glowing ember. Today, it is only 2.7 Kelvin, not because the light has dimmed in the usual sense, but because the expansion of space has stretched each wavelength, reducing its energy. It is the same principle you might imagine with a balloon. If you draw a wave on its surface while it is small, the wave is short and sharp. As you inflate the balloon, the wave stretches, its peaks spread farther apart. This is what has happened to the light of the cosmos. Its waves have stretched over billions of years, turning hot, visible light into cool, invisible microwaves. And yet, even in the vast chill of the universe, there are rare places colder still. One of the most remarkable is the Boomerang Nebula, a young nebula some 5,000 light-years away in the constellation Centaurus. There, gas streaming from a dying star is expanding so quickly that it cools itself below the temperature of the cosmic background. Within that ghostly cloud, the temperature has dropped to about 1 Kelvin, only 1 degree above absolute zero. It is the coldest natural place ever observed, a fragile pocket of silence in an already frigid universe. The knowledge that space is not empty, but filled with this subtle warmth, changed our understanding of reality. It means that every corner of the cosmos is connected by this same invisible light. Even where galaxies fade into the darkness, even in the voids between clusters where no starlight shines, there remains this delicate remnant of the beginning. It is the universe's faint heartbeat, a glow that has endured since the first dawn of transparency. When we measure this temperature, we are not merely recording a number, we are listening to the slow rhythm of the universe itself. That 2.7 Kelvin represents balance, the gentle peace that follows unimaginable heat and expansion. It reminds us that the universe has cooled, matured, and softened, yet still carries within it the memory of its fiery youth. Every star, every planet, every atom exists within this great cosmic sea of ancient warmth. And tonight, as we rest under the stars, that same ancient radiation quietly surrounds us, connecting us to the beginning of time itself.
Chapter 25. Tiny ripples became galaxies. Across the heavens, the cosmic microwave background appears astonishingly smooth, a uniform glow that fills all of space. Yet, when scientists examined it with instruments of extraordinary precision, they discovered something remarkable hidden within that apparent perfection. The light of the early universe carries faint variations, tiny ripples in temperature and density, so small they differ by only 1 part in 100,000. These minute imperfections, frozen into the fabric of space nearly 14 billion years ago, would become the seeds from which every star, every galaxy, and every cluster of worlds would eventually form. To the naked eye, these differences are invisible, but satellites like COBE, WMAP, and Planck have revealed them in exquisite detail. The Planck spacecraft, in particular, mapped the entire sky in microwaves, creating what scientists often call the universe's baby picture. At first glance, it looks like an oval painted in splashes of red, orange, yellow, and blue. But each of those colors represents a temperature difference far too small for any human sense to detect. Fractions of a degree that nonetheless contain the entire story of cosmic structure. In this image, the blue regions mark the slightly cooler, denser patches of the early universe. These were the valleys into which matter would slowly flow, drawn by gravity's gentle pull. The red regions were slightly warmer and thinner, the hills from which matter would roll away. What we see then is a topographical map of the infant cosmos, where gravity was beginning its long, quiet work. These delicate ripples in the primeval fog were the scaffolding upon which the grand architecture of the universe would rise. But the ordinary matter that makes up stars, planets, and people, hydrogen, helium, and the elements that came later, was not alone in this story. The visible matter, though vast, was simply not enough to form galaxies as quickly or as large as those we observe today. The gravitational differences between the dense and less dense regions were too subtle, too gentle. Something unseen had to lend a stronger hand. That something is dark matter.
Dark matter, though invisible, exerts gravity just as ordinary matter does. It does not emit or absorb light, but it makes up roughly 85% of all matter in the universe. In the early cosmos, when the intense radiation of the Big Bang was still pushing ordinary particles around like waves battering grains of sand, dark matter stood apart. It did not interact with light. It did not scatter or drift. It began clumping together freely, forming deep wells of gravity, massive, invisible halos that ordinary matter would later fall into once the universe became transparent. You can imagine the early universe as a vast ocean of glowing gas. The radiation pressure from light acted like restless waves, constantly stirring and pushing the ordinary matter, preventing it from settling. But beneath that glowing surface, the unseen dark matter gathered silently, creating the first gravitational anchors in an otherwise turbulent sea. When the cosmic fog lifted after recombination, the ordinary gas, finally free to move without interference from light, fell into these invisible hollows. Over time, these pockets became the birthplaces of galaxies. Our own Milky Way now sits within one of these immense dark matter halos, enveloped in a gravitational field that extends far beyond the visible edge of the galaxy. Over billions of years, this quiet process shaped the universe into a breathtakingly intricate network, the cosmic web. If we could step back and look at the cosmos on the grandest possible scale, far beyond the boundaries of any single galaxy, we would see a vast structure resembling a three-dimensional web of light. Long filaments of galaxies stretch across intergalactic space, connecting enormous clusters like threads of a luminous tapestry. At the intersections of those threads are massive clusters containing thousands of galaxies, bound together by gravity. Between these filaments lie the great cosmic voids, immense dark regions where few galaxies exist. The pattern of this web, the balance of filaments, clusters, and voids, can be traced directly to those subtle ripples in the cosmic microwave background. The cold, dense spots became the filaments and clusters. The warmer, less dense regions became the voids. From microscopic irregularities, the universe built a structure spanning tens of billions of light years. Every glittering spiral, every faint dwarf galaxy, every blazing supercluster owes its existence to those ancient variations, tiny fluctuations magnified by the slow, persistent pull of gravity over cosmic time. But where did these primordial ripples come from in the first place? Why was the universe not perfectly smooth? The answer lies in one of the most profound ideas in cosmology, cosmic inflation. According to this theory, in the first unimaginably brief instant after the Big Bang, far less than a fraction of a second, the universe underwent an explosion of expansion so rapid that space itself grew faster than the speed of light. During this moment, quantum fluctuations, tiny, random variations in energy that exist even in the vacuum of space, were stretched to astronomical scales. In essence, the largest structures in the universe, the galaxies, clusters, and cosmic filaments, are the amplified shadows of quantum tremors that existed at the very beginning of time.
What began as microscopic, fleeting vibrations in the quantum foam became, through inflation and gravity, the colossal architecture of the cosmos. It is a humbling thought. The dance of galaxies and the rhythm of starlight are, in a very real sense, echoes of quantum whispers from the dawn of creation. As the ages passed, gravity sculpted these ripples into stars and worlds. Dense regions collapsed into burning suns, Clouds of gas spun into rotating disks that birthed planetary systems. In the densest clusters, thousands of galaxies formed together, bound in slow cosmic dances that would continue for eternity. And all of it, the richness of the night sky, the complexity of the Milky Way, and the very world beneath our feet, emerged from those infinitesimal differences, those soft variations in the temperature of a newborn universe. It is deeply moving to think that everything we know and love, the oceans and mountains, the warmth of sunlight, the life that breathes on Earth, originated from such delicate beginnings. Out of a field of near-perfect uniformity, it took only the slightest ripple to give rise to everything.
The universe teaches us that complexity can emerge from simplicity, that great beauty can grow from the smallest imperfections. Every star that twinkles in the night sky is a testament to that truth, a living echo of the faint, uneven glow that once filled the cosmos. And as we look upon the CMB, that ancient light still drifting through the darkness, we are not merely observing a relic of history. We are witnessing our own origins, the moment when the first seeds of order and structure were sown into the vast, formless sea of creation. Those tiny ripples became galaxies, and within those galaxies, the long story of existence began.
Chapter 26: An Expanding, Cooling Universe.
From the very first instant of creation, the universe has been stretching outward. The expansion began in the immediate aftermath of the Big Bang, and it has never stopped. Space itself, the invisible fabric that carries all galaxies, stars, and planets, has been gently unfolding like the slow breathing of an immense and ancient being. As space expands, it cools, its energy spreading ever more thinly across the growing cosmos. What was once a searing ocean of plasma is now a calm, frigid void filled with a faint afterglow, the cosmic microwave background, measuring just 2.7 Kelvin, barely above absolute zero. This cooling is not like the cooling of air or water on Earth. Nothing is radiating heat into some surrounding emptiness. Rather, the very wavelengths of light themselves are stretching as space grows. Each photon that once blazed with the heat of creation has been stretched into long, faint microwaves by the relentless expansion of the cosmos. The universe, once incandescent and crowded, has become vast, serene, and silent. And yet, this expansion is not slowing down. Against what might seem intuitive, the stretching of space is actually accelerating. The galaxies at the edges of our vision are not only moving away from us, they are doing so faster and faster as time goes on. This astonishing revelation, confirmed in the late 1990s through the study of distant supernovae, points to the presence of a mysterious force that scientists call dark energy. Dark energy is one of the most profound enigmas in all of modern physics. It behaves like a kind of negative gravity,
an unseen pressure that drives space itself to expand more rapidly. Unlike matter or radiation, which become less dense as the universe grows, dark energy appears to remain constant. In fact, the more the universe expands, the more of this invisible energy there seems to be, because space itself is its home. Today, dark energy makes up nearly 70% of the total contents of the cosmos. The ordinary matter that forms stars, planets, and life accounts for less than 5%. The rest is dark matter, an equally mysterious but gravitationally attractive form of matter that binds galaxies together. We live, then, in a universe dominated by the unseen, a cosmos where invisible forces govern the largest structures and the ultimate fate of everything. While gravity pulls the contents of the universe together into galaxies and clusters, dark energy pushes space apart. This delicate balance defines the rhythm of cosmic evolution. It is a quiet, graceful dance between attraction and expansion. The expansion of the universe can be imagined through a simple image: a loaf of raisin bread rising in an oven. The dough represents the fabric of space, while the raisins are galaxies. As the dough expands, the raisins move apart, and the farther apart they are, the faster they seem to move away from each other. Yet the raisins themselves do not grow or stretch, they remain intact. In the same way, galaxies and everything bound by gravity, like stars, planets, and people, do not expand with the universe. The space between galaxies expands, not the galaxies themselves. Here on Earth, in our comfortable cosmic neighborhood, the expansion is imperceptible. The gravitational bonds that hold the solar system together, that keep the stars of the Milky Way orbiting their galactic center, are far stronger than the gentle stretching of space. We do not feel it, just as a person standing on the surface of a vast inflating balloon would not notice the surface expanding beneath their feet. For us, the universe feels stable and still, even as it silently swells around us. But this expansion has consequences for the distant future. Over billions of years, the universe will continue to stretch, and the galaxies far beyond our local group will drift away faster than their light can reach us. Eventually, they will slip beyond the cosmic horizon, disappearing from view forever. The night sky will grow emptier as the great tapestry of galaxies fades one by one. Only the galaxies gravitationally bound to our own will remain visible. Chief among them, our nearest large neighbor, the Andromeda Galaxy. In roughly 4.5 billion years, the Milky Way and Andromeda will begin to merge in a slow, elegant collision. Though the word collision evokes violence, the reality will be far more graceful. The stars within each galaxy are so widely spaced that few, if any, will actually strike one another. Instead, the galaxies will pass through each other like ghostly dancers, their shapes distorted by gravity, their gas clouds colliding and igniting bursts of new star formation. Over hundreds of millions of years, the two galaxies will merge fully, forming a single enormous elliptical galaxy, an island of light adrift in the expanding dark. Astronomers have affectionately named this future creation Milkomeda. For any beings who might still exist when that time comes, the night sky will be breathtaking.
The hazy band of the Milky Way will be replaced by vast arcs of light from Andromeda, swelling brighter with each passing eon. Stars will form in abundance as interstellar clouds collide, and for a brief cosmic moment, the universe will seem newly alive with light. But as the ages continue to unfold, that brightness too will fade. Star formation will slow, galaxies will settle, and the great expansion will carry most of the cosmos beyond sight. In the unimaginably distant future, trillions upon trillions of years from now, the universe will enter what cosmologists call the Big Freeze. By then, all the galaxies beyond our local cluster will have receded beyond the horizon, their light stretched into oblivion by the accelerating expansion. Only the remnants of Milkomeda and a few nearby galaxies will remain, suspended in a vast black sea. The stars will gradually exhaust their fuel, fading into cold embers. Even the black holes at the hearts of galaxies will one day evaporate, releasing their last whisper of energy into the darkness. The universe will not end in fire, but in silence, a slow drift into stillness where everything is diluted into near nothingness. Yet there is a quiet beauty in this fate. The same cosmic expansion that gave birth to stars and galaxies will also cradle their final moments. It is the natural rhythm of a universe that creates and disperses, heats and cools, expands and fades. And we, existing in this brief, luminous middle chapter, are witnesses to its splendor. From our small blue world, we can look outward and see the glow of the beginning, the dance of galaxies, and the calm stretch of time itself. The knowledge that everything is changing, that even the sky above will not remain the same, need not bring sadness. It can bring peace. For the universe is dynamic, but its changes unfold over scales so vast that we are free to live our lives within its serenity. We inhabit a fleeting yet beautiful moment in cosmic history, balanced between the brilliance of creation and the quiet of eternity. The universe expands, it cools, it evolves, and we, for this short while, have the privilege of seeing it, understanding it, and feeling awe at its graceful unfolding.
Conclusion: Finding stillness in the stars. Our voyage from Earth's familiar shore to the farthest edge of the observable universe has been both a journey outward and a journey inward. As we travel through time and space, through the birth of light, the quiet growth of galaxies, and the patient cooling of the cosmos, we begin to feel something shift within ourselves. The universe, once distant and abstract, becomes a mirror of stillness. Its vastness, rather than making us feel small, draws us into a deep calm, reminding us that we are part of something steady, ancient, and profoundly ordered. When seen through this tranquil lens, the facts of astronomy transform into gentle meditations. The speed of light becomes not a number, but a reminder of patience, of how messages from the past still arrive, carrying the stories of stars that died long before our world existed. The expansion of space becomes an invitation to breathe and to let go, to understand that everything in existence is always in motion,
always unfolding with quiet grace. The cycles of birth and death among the stars remind us that endings, too, are beginnings, that nothing truly disappears but changes form in the continuous rhythm of creation. Even the cold silence of intergalactic space holds meaning. It teaches us that stillness does not mean emptiness, it means balance. Beyond the noise of daily life, beyond the rush of thought and obligation, there is an underlying quiet, the same quiet that fills the cosmos itself. To sense it is to feel aligned with the heartbeat of the universe. In this awareness, our anxieties take on their proper scale. They do not vanish, but they soften. The perspective of billions of years and trillions of stars helps us see that our troubles, no matter how immediate, belong to a larger, unfolding story, one that has endured with grace since the first dawn of time. Like dust drifting in sunlight, our lives move gently within that glow, brief yet beautiful, transient yet meaningful. The cosmic perspective offers comfort without illusion. It reminds us that we are both fleeting and eternal, momentary sparks of consciousness woven into an ancient, living universe. The same atoms that form our bodies were born in the hearts of stars, scattered across the galaxies, and gathered again into the shape of us. To realize this is to find peace, not by escaping the world, but by seeing it as part of a grand, serene whole. So as we come to rest at the end of this journey, let the stars above remind you of stillness. Let their slow, unwavering light soothe you. Somewhere, beyond the reach of time, the universe continues its graceful expansion, calm, patient, unhurried. And in that vast, enduring silence, we too can find our place, small, luminous, and at peace.